Mhm. Good morning. I'm so glad you've joined this online training session. I'm Dr. Derek Fish. I'm Director of the UniZulu Science Centre, and I'm delighted to be working with the South African Institute of Physics on this project. You're going to get some fantastic help this morning from some of the best experts in the game. The only problem is that after 2 hours, that help will be over. I want to tell you about some resources the Institute of Physics has made available, which will continue to help you throughout the year, anytime you need them. And the best thing is, they're absolutely free. Let me tell you about the essential skills resources, which I developed in 2020 during COVID. I've been running matric workshops for over 30 years. And during 2020, when we couldn't go to schools, we made videos of all these resources. We called it essential skills because of the idea that facts fade, experiments expire, but skills stick. And every year, the examiner identifies the fact that the main thing lacking in students is not so much knowledge, but the skills. So this was the basis. We identified 4 essential skills for physics for paper 1. That was graphs, free body diagrams, solving equations, multiple choice and ratio questions. I'll show you how these skills cover all 10 of the questions in paper 1. Graphs we further broke down into 4 examples: motion graphs, photoelectric effect, Ohm's law, and internal resistance. And again, this is the comment from the examiner himself. A severe lack of skills is evident: mathematical, conceptual, and integration of topics, free body diagrams, graphs, and equations. So that's what we have tackled here. The section on equations, we expanded to actually cover all of those long questions which involve solving equations. Now, you will see that every single one of the questions is covered here, not necessarily in the same order as a textbook. And these videos and the booklet that goes with it are not a textbook. They do not replace your textbook or your teacher or your notes. They're a revision tool for you to use in preparing for exams. Use them immediately in preparing for June. Use them again in preparing for September trials, and especially for your finals in November. So they're grounded on the curriculum. The relevant theory is covered, but just in brief. Experiments are performed, simulations studied, and exam questions are explored, not just in giving the answers. You don't need that because you have memos, but just explaining strategy and how to answer that. There is a booklet which you can obtain through the Institute of Physics, or otherwise I'll show you how to download it from the website. This is the contents page, and you can see the skills, graphs, free body diagrams, equations, multiple choice. The equation section in red is much longer and is actually expanded to cover all the different types of equations which will come up during that exam. And again, a comment from the examiner: learners still cannot work with scientific equations or formulae. When the theory is covered, it's covered in a very interesting way. For example, you'll talk about Doppler effect today. I use lots of exciting animations to make the concepts clearer. There are also lots of summaries. The strategy for problem solving will be introduced, and a summary of all the graphs of motion that you will come across in matric. And this very useful table for choosing the correct equation of motion when you might not be too sure, particularly for projectile motion, question 3. I cover the syllabus experiments, and for example, this is the internal resistance experiment. And it's covered using fantastic Pasco software and hardware, so you can actually participate in the experiment. Also, lots of useful considerations, particularly from PHET. The photoelectric effect, you'll talk about projectile motion today, and also momentum. Then talk about applications like what would the International Space Station be without its. When we talk about exams, we make comparisons of at least 3 years of exam questions, looking for common trends and strategies that you can rely on. And let me tell you just how to get hold of these. If you go to the Institute of Physics website and you look up matric material, it'll take you to this page. If you scroll down on that page, you simply ask to fill in your details. This is just so that we can track the use of these resources, but the resources are absolutely free. Press the submit button, and that will take you into this Google Drive where all the materials are available, either to be used online or to download. Here I am on the actual website. You can see all the different files that are there. So the main physics videos are in this folder. If we double click on that, then you can see all 16 of the videos. They're about an hour long each. So this is not something you should use only in November. Start using these fantastic resources now, and they will help you throughout the year. Here are the booklet parts, and you can see their PDFs. It's just a few pages at a time. For example, if we open the one on graphs, it will show you a PDF with all the relevant pages that you would use and fill in all the exam questions while you are actually watching the video on this point. These, of course, you can watch on screen, or you can decide to print out. We also have exam papers and exam memos, and you can see you don't need to go to the website to look these up. Here are all the physics November exam papers from 2014 all the way through to current. Don't go back before 2014, because that was before the CAPS curriculum. So everything you need is here. There are also all these things for chemistry as well, but we're going to talk about that next Saturday. There's a promo video, a letter explaining things, and all the contents. This is a fantastic resource, and I hope you're going to make the most of this. And you can pause it, fast forward, or rewind as much as you want. If you don't like the sound of my voice, you can just mute me. I wish you all the best for your exams. I won't wish you good luck, because that only helps with the multiple choice. But I hope you'll work hard and join us in the physics community in the future. Thanks for watching.
Hello, Itumene. How are you?
I'm good, thanks. I'm
Great. Thank you so much for joining us.
yeah.
Why is the study of science so important?
Study of science is important. Let me speak directly to physics. Physics is vast, and there's a lot to learn in physics. There's a lot to learn in a sense that you wouldn't know if you're just sitting out there not doing anything. Just reading and doing, like reading can make you realize a lot of things, especially with physics. Like myself, I didn't know about this resistive switching memories up until Dr. Dlamini from the Central University of Technology introduced this to me, and then it caught my attention. And say, yeah, with all the challenges that comes with it, I just felt like, you know what, I'm up for the challenge. Let's go, let's do it.
Let's do it. All right. So I know that there's a lot of young people who are in high school who are quite skeptical about venturing into careers that have to do with physics specifically. What advice would you give to such a young person?
I would speak to say, not giving up. I was in high school at some time, and they wouldn't believe me when I say I did fail physics and maths. I did get 0 at some point.
Seriously?
I failed grade 10 3 times.
But look at you now.
Now I'm doing PhD. Looking back, it's like, it never happened. So yeah, not giving up. Just like have the intention, the dedication to do what you want to do, what you have to do.
And of course, resilience,
Yes.
perseverance, it becomes very important.
Now,
Just like yourself, I am a product of SMU, Sefako Mahato Health Sciences University. And I think that being in such an institution where you are exposed to different people from different walks of life, and eventually when you go into the science stream, the physics stream specifically, then you start to see just how these concepts can be applicable in our daily lives. Just really makes you fall deeper and deeper in love with the subject itself. Was that for you as well?
yeah, it was the same for me. Like I said, somehow I did get some zeros there.
Yeah.
But then through dedication and, coming from where I come from, and you are at this side, you've made it to university. Somehow winning is the only option. You have to win, like it or not. So going back to where you come from, you're just going back to that life of drugs and whatnot. And that's not an option, I guess. So winning was the only option coming this side.
So we are in June right now, and learners are writing their June examinations. So to those who are writing physical sciences, what words of encouragement would you like to share with them?
I think study study before, like you prepare, like you always prepare yourself to writing. You can be a genius whatsoever, but then if you're not studying, preparing for your exams, I don't think somehow you're bound to fail. So preparing for your exams in time and making sure you consult your teachers and whatnot. I think you'll get there eventually.
You know what they say? If you fail to plan, you plan to fail.
Yes.
So study and be prepared. And there's no need for them to be anxious or nervous. I mean, if you could fail grade 10 three times, and now in 2025, you are a PhD student in physics, anything is possible.
And I'm a lecturer, by the way. I'm a part-time lecturer at the physics department.
Listen to that. Listen to that. Thank you so much. We really appreciate it. What's the future looking like?
The future is looking to resistive switching memories. I think, the future just looks bright. I think it's going to do wonders in the future. And I'm just looking forward to that. Also, in the academic area, I think so far so good. Lecturing is going well. And I think, everything about the future just looks bright.
Okay, thank you so much. All right, ladies and gentlemen, my name is Mukosi Mashela. It's a wrap. Thank you so much for indulging us in our conversations. Until the next one, bye.
I'm Jade Morano. Ever since I was younger, I would gaze at the stars with my late grandmother, and from there on, I've had this deeply rooted passion to understand the universe I would look at all the time. It enables me to one day come up with an innovative idea or discover something that could benefit our society and help us grow scientifically. Honestly, every topic involving the stars and astronomy really excites me since it's very much up my alley. I aspire to become a theoretical physicist, so mathematics and physical sciences are fundamental subjects required to pursue my career. Physics can be challenging, but very rewarding. So always test your limitations and surprise yourself. I think that physics is seen as a male-dominated industry. So I would like to flip that perspective and challenge all young women out there to believe in yourself and to really test your limits and see how far you can go in physics to change this perspective. Yeah.
My name is Tamaka Madicha. Having the passion to acquire incredible knowledge, as physics is that one subject that defines life as we know it. Having to do calculations and learning knowledge that's beyond every other subject, like geography or history, physics is just that one excellent subject. Everything with physics in general, especially calculations, makes me want to learn more, as physics can prove life as we know it. I'd like to become an airline pilot, And physics in the aviation sector will help understand aerodynamics, including lift, drag, or airflow, which will help engineers design aircrafts and the technologies. If you love it, it will be excellent for you. Physics, when you learn physics, you step into a different dimension. So do it with passion, do it with love.
Physical science is very bad, then it means the whole science, engineering, and technology is bad. And we also call it the physics of today is the technology of tomorrow. I think those of you who have been listening to the news, you heard that the Nobel Prize for this year was given to the people in physics who invented AI. I think most of you are using AI, Snapchat, and so forth, but that's from physical science. So maybe next time it will be one of you discovering that. And here is a lot of the areas in which physical science people work.
So think about the physics. They're saying, be in the kitchen, make use of that kitchen to be a genius. Brian has said what a genius is. So I am saying, you are all geniuses. You are all going to make it. What I want to tell you is, believe in yourself. You are going to make it. You can do it.
Which topic is difficult? Which do you think is difficult? Yes, with energy and power. You know why you say it's difficult? You say it's difficult because when they ask you and say, use energy principle, you don't know which one to use. And the heating on the surface of this metal, and then if the frequency is of high enough energy, we are going to have what? Electrons ejected there. And you can even see that with these ones here, where are the electrons themselves? Because they are going to be ejected with different velocities, depending on where the electron was. Let's say the electron was somewhere here. Here, it's there. It means that the light will come down to there, impinge on that electron, and then the electron will go that way, assuming that there are no collisions at all. And then if there are collisions, it's going to reduce the kinetic energy of that, and then it will dash off. Okay, and then this one. Right, can you give me the answers now? I think you are now fine. I don't know whether you're all right. But Ara, which one? Oh, sorry. Who said that? You. Tell me, which Ara? The small R, yes.
You say rise, A plus B with C. Initially, I have X of that, which is this one here, and nothing of it. Remember? Now the change comes. This is decreasing. You see that? I will have my minus T and a minus T. And in the meantime, this is starting to increase. Hence, I have my plus T. And then at equilibrium, this is the end of your reaction. Nothing happens anymore. You are now on this block or portion. This is the equilibrium that you have here. Right. Hey, I'm not going to complete this one. You can leave it there for now.
7, 6, 5, 4, 3, 2, 1, 0.
Good morning. Good. Brian, tell me if you can see my screen.
Yes, I can see your screen now.
Okay. Just want to make sure that I'm sharing. I don't see it from my side.
And it's also not on presentation mode.
Okay, let's try that and see. Is that okay now?
Yes.
Tell me if you're seeing double screen or single screen. Tebogo? Tebogo? Tebogo?
Yes, I can see it, Marv. But it's not
Oh,
in,
okay.
can you put it in presentation mode? It's double.
It's double. Okay, so it's vice versa. Okay, it's fine. Let's do this.
Yeah, and you can put that one in presentation mode.
Is that okay now?
No, still double again.
Still double. What's happening here? Okay, let's do this. I think the problem is here. Okay, do this. That should be fine now.
You are not sharing anything at the moment.
Not sharing anything. What's happening here? And presentation mode.
Yeah. You
It's
just
fine
need to
now.
put it in. Yeah, you just need to put it in presentation mode.
It's the same thing. Slideshow. Okay, let's continue. We'll see if you can see that screen. That's fine. Are we okay?
No, you are on your image.
Hey man, what's happening here now? I'm sharing on the other side.
Yeah. Yeah, now it's sharing the slides, but I think you have moved. You are not on the first one.
Yeah, I am on, from my side here. I can't actually see what you are seeing there. I'm not sure what is happening. Let's try this again and see. Amen.
Okay, yeah, now it's fine.
It's fine. Okay, thanks.
Yeah.
Okay. Yeah, morning, and my apologies for the inconvenience. We are going to do this metric physics preliminary workshop for your exams. And the physics team that will be giving this workshop is myself, Dr. Molf and Mr. Kwanda. We are both are from the University of Johannesburg. And I'm just going to give you a small brief of what we'll be covering in relation to physics. By simply reviving this, the physics knowledge that you guys have from the previous workshop that we had in May. So things that we spoke about then is physics is related to topics like your matter, and you also have the charges, you have the waves. But beyond that, when you look at the matter itself, you'll be looking at the particles and solids, liquids, and gases. And this forms part of the mechanics. And being a part of the mechanics, these are the quantities that we'll be working on in this workshop, being the energy, the mass, the velocity, forces, momentum, you name all these quantities that you know that we are going to be dealing with. We're also going to look at the charges, and the charges are related to matter. Again, with interest going to be the positive, the negative, and the current, and all of them. When we look at them, we'll then be emphasizing on what is that positive and what is that negative, what is that current that we'll be talking about. So you will see as we work out the problems that we'll go back to this, and this forms part of electricity. Again, there are quantities of interest when you study the electricity, that's the energy, and you see that we spoke about the energy earlier in mechanics and electric current, which are part of what I've just spoken about down here. And when you look at the electric current, there are a number of things that we're going to be looking at and trying to be able to calculate and reason them out between some definitions, which is, your current, your potential difference, CMF, your resistor and resistance. And we're also going to look at the waves. And when you look at the waves, you'll see that the matter comes back in terms of the mechanical waves. And we're also going to look at the electricity again in terms of the electromagnetic waves. And basically, you can link a matter with these mechanical waves. And further on, we linked the electromagnetism with the charges. And all this then leads to what we are supposed to be doing today. As one, we're going to look at the multiple choice. And I want to give you a brief of how to answer the multiple choice, the things that you need to take care of, which are very important when you answer the multiple choice questions. One, for you to improve on your multiple choice test performance, start by reading the entire question and all options before selecting an answer. It's very important. The second one, use the process of elimination to remove obviously incorrect choices, focusing on details like extreme wording, always, never. You look at the third one here, then when you are unsure, I say make an educated guess. Don't leave questions blank or unanswered. Consider skipping difficult questions to return to them maybe at a later stage when you still have time. But when it comes to your multiple choice and you don't have the correct answer that you are sure of, you can always play a lotto. But before you are answering any question, read the directions that are given carefully to understand what is being asked. Again, read the entire question and all answer choices that are given before selecting a correct answer. Cover the choices and try to answer the questions in your own first word. Try them first before you even look at those choices. That is going to help you to come up with the most correct answer. And when you're answering those multiple choice questions, one of the key words that we normally take is eliminate the incorrect options by crossing them off or mentally disregarding them to say these 2, 3, they're out. I cannot take them. Look for the patterns in the options or common wordings that are given there. You'll see that some questions they've got, similar words, but there is one minute thing there that discriminate them to make sure that you get the correct one. Be aware of absolute qualifiers like always, never, or all, as these are often incorrect. Watch for relative qualifiers like usually, generally, and sometimes, as these are often correct because they allow for exceptions. This is very important, when you work on the multiple choices, that before answering, you look at this four that I've just mentioned now. The last one being, be suspicious of identical or opposing options. One of them may be the correct answer. And the very last one that we can look at is you then have a chance to look for the best or most correct answer, as multiple choice might seem right, but one of them is more superior. And you'll see in the next questions that we'll be answering that all that I've spoken about are going to be applicable. Pay attention to the grammar. It is very important because the correct answer will often be grammarly consistent with the question. And when you answer those questions, try to finish the sentence with the option that you are taking. You'll see that, the grammar will help you to see the correct answer and pick it up and say, this is the one. Consider if questions ask for exceptions, not or except. And again, this gives you an indication of which option you can actually take as an answer. Now let's take the first multiple choice question, and the question paper that we are going to look at is the 2024 November paper. And we chose this one because it's more recent. And, examiners always work on the very recent paper because they do give us the diagnostic report where they actually tell us where the students or learners couldn't get enough marks. And based on that, we thought this will be the best question paper to work on, given that we've got 3 hours. And you can always go back to this question paper and look at the memorandum. And you'll see from what we are doing here, we're answering the same questions with the same memorandum, but we're putting some more emphasis on how best you can answer these questions. Let's look at the first question here. It says, a constant net force is applied to a block. Which one of the following statement is correct? And if you try to eliminate, you might think that is easy because I said eliminate the incorrect answers. If I look at this, the first one, the A, constant velocity, it looks so correct to me. Constant acceleration, it doesn't look correct to me. Constantly increasing acceleration, oh, this could be the correct one. Constant decreasing acceleration. Now there is the contradiction that I was talking about. Then I can see that these two are definitely out because there is a contradiction, but I'm not really sure because I cannot justify why do I eliminate them. So what we need in this kind of instance, because they said the constant net force, then I can actually jump and say, I know the definition of a net force or the resultant force, which states when a resultant or a net force acts on an object, the object will accelerate in the direction of the force. The acceleration is directly proportional to the resultant or the net force and inversely proportional to the mass of an object. Now, I've got an acceleration from this definition. And initially I said A could be correct because it has the constant velocity and they spoke about the constant net force. But now I see from the definition of a net force that acceleration I know is equals to the change in velocity over the change in time. Therefore, if A is my option, then I'm going to have a constant velocity. And if I look at the acceleration with a constant velocity, that will mean my acceleration is going to be equal to 0. And if that is the case, from this definition again, since it said here the acceleration is directly proportional to the resultant or the net force, so that will mean my acceleration is equal to 0. So there is no option like that one. The constant velocity will be out. But the next one, which is B, it says constant acceleration. And based on this statement again, the acceleration is directly proportional to the resultant or net force. Then I can confidently choose number B because I can see that that constant net force that will be applied on this block will be equivalent to the constant acceleration because they're directly proportional. Therefore, B will be the correct answer. And the last two, as I said, they are good distractors. I've already eliminated them. Then I'll go on and say, but then there's another definition that I didn't use, which someone could have picked it up, which says the net force is acting on an object is equals to the rate of change of momentum of the object in the direction of the resultant or net force. This is also correct, but does not help me to answer this question. But then what comes in mind is then what is said by the examiner's guideline. They say define the resultant force. So it's either you give the first one that I gave here or the second one, both of them. They're going to give you full marks, provided all the key underlined words or phrases are correct in the context. If they are not or they're omitted, then they're going to take a mark for each that you don't have that is directly linked to showing your understanding of the definition. So as it says here or is shown here, I know most of us we've been told we must give the definitions as they are in the textbook. It is not really true. If any of the underlined keywords or phrases in the correct context is omitted, deduct 1 marks. That's the only way that you can lose marks. But if you state either of the two, it shows that it cannot be that it must be word by word. But you need to know that you need the resultant force equal to the rate of change of momentum of the object in the direction of the resultant force. That gives you 2 marks. If you use the first one, the acceleration is directly proportional to the resultant net force or inversely proportional to the mass of the object. That will give you the marks. So the correct chosen answer is B. If you work from the memorandum that is given, they will simply tell you that the answer is B. But how do you get the B is not explained. So this is what we are trying to show you on how to get the correct answer using the definition and the knowledge and the content and concepts that you have learned in class. So everything that you have done is relevant to answer these questions. Let's try the next question, multiple choice question, which is in a different format. Here, now we see that the projectile motion comes into effect here. It says a stone thrown vertically downward. Now again, thrown vertically downward from the top of the building takes t seconds to strike the ground. Consider the acceleration time graph below for the motion of the stone. The effects of air friction are ignored. To enable you to answer this question, what does the shaded area between 0 and t seconds show in the graph represented? Oh, they are talking about acceleration and time graph. If I look at this, it talks about number 1, the final velocity of the stone, the change in position of the stone, the constant velocity of the stone, the change in velocity of the stone. All of them, they look so correct. But I can't just be able to give which one is correct unless I've got the memorandum in front of me and I look at it and I say, yes, this one sounds correct. But because I've learned the definitions and I know the definition of acceleration, which is given by A equals to V2 minus V1 over T2 minus T1. And because I'm told that is thrown downward, then the gravitational acceleration comes in. Then I can look at the gravitational acceleration in terms of its magnitude. And Because I want to get a better understanding, I will then say, let me take the downward as positive to make this then to be a vector so that it's easy for me to work with it. In a different problem, I will have the g to be equals to negative 9.8 meters per second squared. But for now, I want to take it as positive. Then I say, but I've got this. How does it help me to answer that? I'm not yet there. But then from the mathematical point of view, I know that the 9.8 meters per second squared can be given as 9.8 meters per second. Then this interpretation will help me to answer this question, because by virtue of having the 9.8 meters per second being the velocity, then it means this stone, as it travels downward, for each second, its velocity is changing constantly by 9.8 meters per second. Thus, I will then go back and look at my A, B, C, D options and see if this will help me to answer this question. The first one says the final velocity of the stone. It can be correct. The definition is not agreeing with that statement. The graph shows that the change in position of the stone, no ways. I don't see a change in position of the stone. This is not a displacement. Then I can say this is what I know from the definition of the displacement. The constant velocity of the stone. Wow, this question is similar to the one that I've just answered from the same paper. Constant velocity means I'm not going to have the acceleration. It's also out. It can be. Therefore, the final one, the change in velocity of the stone. This makes sense. The change in velocity, 9.8 meters per second, is that velocity is changing constantly per second. So every second, my velocity is changing by 9.8 meters per second. Thus, the correct answer is D. I've now shown how I got the D to be correct. But again, the memorandum is not telling us why the D is correct. So we need to go back and look at our definitions to justify what the memorandum says. With this said, we'll encourage you, when you look at these multiple choice questions from different question papers, even though you are given the correct answer, get the reasons behind why that answer is correct. Then that is going to help you to answer even questions that are beyond the multiple choice. But again, as we have seen now with this 1.2 and the 1.1, they're asking the same skills. And the same content is also being covered. And you are forced to see if your answer for A was incorrect because you said constant velocity. You are able to correct it now when you're doing 1.2 because now you have better your understanding of answering that question. Then go back to that question and correct it to get the answer that you are envisaging to get to be the correct answer. Now let's do this one, which is 1.2 from a different paper. But again, what we want to show you is the skills to answer this multiple choice. A crate of mass M is stationary on a plane inclined at an angle of theta with the horizontal. You see the mass M at an angle of theta. It is there, it's stationary. That's what we are told. Then they say, which one of the following statements regarding the magnitude of the frictional force acting on the crate is correct? Then the statement reads, the magnitude of the frictional force acting on the crate is A, equal to the component of the weight of the crate which is parallel to the plane. The second one, larger than the component of the weight of the crate which is parallel to the plane. Larger than the component. No ways. If it's larger than that, then it means it must be traveling somewhere because Newton's second law said the net force acting on that object of mass M will be accelerating in the direction of the net force. So it cannot be equal to the component of the weight of the crate, which is perpendicular to the plane. Perpendicular to the plane, maybe. Let me look at the first one, the A equal to the component of the weight of the crate, which is parallel to the plane. Wow, there's a contradiction here. Am I going to cancel them because I said if there's a contradiction, I must just remove them? I need to justify why do I remove them. The last one says the larger than the component of the weight of the crate, which is perpendicular to the plane. Again, larger than the component of the weight of the crate, which is perpendicular, by virtue of having that component being larger than, it means that should be traveling in a certain direction. But the statement said, stationary. And by virtue of that being stationary, it means there are two of them that I can eliminate. But I'm not confident yet of how to eliminate them. So what am I going to do? I'm going to draw a free body diagram. And that free body diagram is going to help me to choose the most correct answer here. Then as I draw the free body diagram, this is what I'm going to be doing. So yes, you can have this as your mass M. Write it there. And you can draw this free body diagram with me. Give you a second to have this diagram so that we draw the free body diagram together. Have your rough sketch. Give you a second to have that so that we draw it together. And out of that drawing, you'll see next questions will be easy to answer because now you'll be understanding how to draw the free body diagrams. Ready? Let's go with the first one. You'll see I'm going to use the physics and use everything that I know that I've been taught in class. I'm told this line that I'm drawing that is perpendicular to the surface of this object, this must definitely be by a normal force. So you can write it as a normal force the way you guys write normal force in your school. Write it as a normal force and make sure that it's perpendicular to this surface. And I know somebody will say, but we are told to use a particle like minute thing. Don't worry about that. This is just helping us to draw that diagram and understand it much better. Then the next thing that I know is this one is facing downward towards the center of the earth. What is this? This is my weight. Again, I give you an opportunity to write the weight. The way you guys write it in your own school, write that as a weight. Then I've got these two that are easy to get from the definitions. But then if I leave it like this, it means if I look at the normal force is the only force that is acting there, that means this object must go upward because Newton's second law says this force is the only one in this must go upward. But we're told that it's stationary. Then it means there must be an opposing force. That opposing force, I'm going to draw it. Oh, before that, yes, no, I forgot to talk about this friction because I want you guys to use the given information first. The friction is what is also being given. That the magnitude of the frictional force acting on the crate, so we need to get that. So again, you'll write this as your frictional force acting on that. And I'm going to leave it to you without telling you whether it should be the static or the kinetic. You know now which one is going to be correct. Please write the correct one. Then, from there we say, again, the upward force that is there will make this object to go up because it's only that frictional force that you have. You've got the weight here that is pulling this downward. Fortunately here, at least I've got the leeway to say, no, it cannot pass through this inclined plane. But the normal can make this to move upward. Therefore, I'm going to draw the next force, which is going to be this one over there. And this force is opposing the normal force. And from what we did in the first semester, first workshop that we had, we said we are going to draw the Cartesian plane. Excuse me. We are going to draw the Cartesian plane here. If you like, draw your Cartesian plane. So this is going to be your y that is positive. Draw it in your own diagram, positive y. Then this will be the negative because it's facing downward. And I'm going to have the x-axis in that line. So this is going to be my positive, and this side is going to be my negative. Therefore, this will be my next component. Without showing where the theta is, I can then say, I know this is my perpendicular component to the surface. This I'll just name it to be my perpendicular component to the plane. According to the statement here, we rather use the plane. And this is going to be parallel. This is going to be parallel to the surface or the plane. Therefore, these are all the forces that I have that are drawn according to the information that is given. Therefore, the correct answer here will be the magnitude of the frictional force acting on the crate is not A, but equal to the component of the weight of the crate, which is parallel to the plane. This and that, they must have the same magnitude, but in opposite direction to keep this static. This and that, they also do the same thing. But remember, the question here, or the statement said, the magnitude of the frictional force acting on the crate is equal to the component of the weight. The component of the weight that is parallel is going to be this one. I guess from our drawings now we got it, which one is the correct one. I'll go further and say, put the theta here, put the theta in a diagram there, and use our trigonometrical ratios to then tell me what will be this component here and what will be that component. You can put that on the chat very quickly. You tell me what is your parallel or the component that is parallel, which is this one, and the component that is perpendicular to the plane. You can put that on the chat quickly to tell me which one is what. So let's see if we're going to get that right. Check the chat there. The chat. Can you help me with the chat there if you have the answers, just to tell me what is it that they've written? I can't see it from my screen, so that we know if our learners are able to do the right thing. Are we getting the answers? Okay, I can get the chat here. Okay, I can see it somewhere. Let's see. Parallel component is sine of theta perpendicular to the component. Oh, parallel component is sine theta. No. The perpendicular component is cosine of theta. No. Then there's one that says FG parallel is equals to FG, the sine of theta. That is correct. The other one said the FG parallel and FG perpendicular. No, I'm not going to take that one. Parallel component is sine of da. Now we read that one. Parallel mg, the sine of theta. Correct. That will depend on your own diagram. So I'm happy with some of the answers, provided you write them correctly. Remember that FG parallel is what you have written in your diagram. The FG perpendicular is what you have written. The way you have named your own diagram, that's how you are going to be consistent to then give that. So you can see now from this multiple choice question, how many areas of physics have we dealt with? We have done the definition, we have done the drawing of the free body diagram. Now we've also went as far as naming the components themselves. Then I'm saying to you, in order to get questions related to this incline and any other that needs you to draw the free body diagram, make sure that you have all the forces that are acting on that object drawn. Then you're going to get it right. In relation to this, I know the memorandum is not drawing this like I've done here. Preferably go this route. Then you can take this force, you can take this parallel component, you can then put it there as they have it in the memorandum. But at least you know where it's coming from. This is how I drew that. Then let's see, we want to answer the second question. Tebogo, there's somebody that is able to work on my slides and is disturbing me. Okay, let's look at question 2. Let's try this question 2 here. In an experiment, a crate of mass of 8.5 kilogram lying stationary on a rough horizontal table is connected to a mass hanger by means of a light inextensible string passing over a frictionless pulley as shown in the diagram below. Mass pieces are added to the mass hanger and the acceleration of the crate is measured. The experiment is repeated several times by adding different masses to increase the hanging mass each time. Then Newton's second law comes in again. And this is also hanging. Then it's also telling us about the acceleration in that direction. So you can see I'm working back and forth with definitions. Now let's see if we try to answer this question here. We'll go to the definition. They say define the term static friction. Now in that definition, it says the force that opposes the tendency of motion of a stationary object relative or parallel to the surface. Importantly, these are the key ways that they want: the force that opposes the tendency of motion of a stationary object relative to a parallel or parallel to the surface. Then if you go back to a diagram, you see that then it means if I had to draw the free body diagram here, which I'll want you guys to draw on this diagram here in your own piece of paper or the book that you are working at, you have this as now the tension. Good. This is not moving, but if I only have the tension in that direction, it means it must start moving in that direction. Therefore, it means I must draw the force in that direction, which is going to be the static friction, which has the tendency to oppose the motion of that stationary object. Then I'll come to this mass hanger again, draw what I'm going to have here in terms of the forces. I'm also going to have the tension going upward and the weight. Again, as I said, you write the weight as you define it in using, from the textbook that you are using or according to your school. Then you can see that with this one, I've got all the forces that are acting on this object here of the mass hanger with those multiples of mass pieces that are added. I only have the tension and I also have the weight. But here on this crate here, what do I have? I said I've got the tension and the frictional force. Are there no any other forces that are acting on this object? If there are any other objects that are acting on this object, could you please type on the chairs to tell me which forces are those? Quickly give me the other forces that are acting on this crate, except the tension and the static friction that we mentioned. The Fn and the Fg, the normal force and the Fg, correct. Those are the two forces that you must add in your own diagram. Have those two forces added in your own diagram. Now let's try to answer the second question. in terms of the memorandum and in relation to what we have just done. They say here, draw a label-free body diagram showing all horizontal forces acting on that crate just before it starts moving. The question is clear. It says, draw a label-free body diagram showing all the horizontal forces acting on the crate just before it starts moving. It is not telling us about the normal end, the weight. It's only talking about the horizontal. So if that's the case, this is the one that they were expecting. The one that I gave you and asked you to draw is what is related to what the physics tells us. But fortunately, the examiner says you need not to be penalized if you have the vertical forces shown in your diagram, because the examiner knows that you are definitely going to need those in the next question. But he was only tricky here to say, I want you to give me all the horizontal forces. They only wanted the horizontal forces. But because they understand the physics, they don't punish you for having those two forces that I said you must act. And they say acceptable labels will have the static friction and the tension. And you see, then you've got that minute thing that you have another person from another textbook. They are using a smaller yana box. They have the same meaning depending on the taste of the person that wrote the textbook. Then they also further tell us how are we going to get the marks. A mark is awarded for a labeled and an arrow. So you label FS and you've got the arrow showing that direction, the tension showing that direction, that is going to give you a mark. If arrows do not touch the dot, that is that, the line with that arrow is not touching that dot, then you're going to be given half mark because you are not talking about the same. You are detaching this from what you are talking about, which is that crate. So it's not having that effect that it must have. Any other additional forces except the weight and the normal force, half mark. Why is that emphasized? Is because we're told to draw the labeled free body diagram on the crate, not any other thing, but the crate. So you cannot have the weight of the table and attach it there. So you're talking about something that is not what you're asked. If everything correct, but no arrows, again, half mark will be taken. So you can see that the examiner is absolutely directive to what will give you marks and what is not going to give you the marks. So I hope the 2.1 and 2.2, we have dealt with them and everybody can do that and get the marks. Now that diagram that we have drawn, we are going to need it as we continue to answer the next question. Let's try 2.3 now. The 2.3 says calculate the coefficient of static friction. Now, for me to be able to do that, I need my free body diagram. This is the free body diagram that I ask you guys to draw. And in that free body diagram, you have your normal force and you've got the weight, depending again on your notes. What is it that you write? But then, for me to know whether this is going to be correct or not, I'm going to look at the two masses of the two objects that I'm given, the crate, and I want to know, option 1 says, for hanging mass. And I'm going to show you something that is nice for those of you that want to use the mathematics to help you to get the physics correct. We have a problem with what is written here. As much as it gives us a correct answer, the physics is lacking on this. For a hanging mass M, F net is equals to MA. Newton's second law tells us that. We are happy with that. And because this is stationary, the A is equals to 0. Therefore, this will be equals to 0. if we come back to that, or you come back to this and say, what I have here is the mg on this one, the mg and the tension. So what they've done here is to say the mg is positive, and the T is negative, equals to negative or positive MA, but then the A is equals to 0. So I'm going to remain with mg minus T. Or the other way around, the T minus mg, it means you would have had your m into negative A to make sure that you're consistent with the definition of Newton's second law. But what I want us to take into cognizance here is we've got the m here, and let's go down a bit. We'll come back to that. Again, I've got the m, and these m's are not the same. Yes, they've said force for hanging mass and force for the crate. I'll rather prefer to have the mass of the crate and write it here as m sub c for h, which is for hanging mass. And this one over here, I'm going to write it as m sub c for the crate. Now I've differentiated the masses. If I work with these masses, I'm able to know which one do I substitute where. So please, do me a favor. In your own working, write MH for the hanging. Then we'll look at the statement, go back to the statement to see if we are going to get the mass that we're looking for. Then here, yes, Koketso, unmute and ask your question, Koketso.
So, sir, my question is it always the case if we are dealing with an horizontal plane, is it always the case that the normal force is equal to the force of gravity?
No, not. Remember the previous question that we had on an incline. The normal force was not equal to the weight, but it was equal to the component that was perpendicular to the surface. So only on the horizontal surface that you are going to get this kind of a diagram that I've drawn here. I hope I've answered you, Koketso. Then let's go back. We said we're going to name this as MH. Then it means the second one, we're going to name it as MC. Now, why am I emphasizing on that? Some of you might want to use the simultaneous equations. And if you're using the simultaneous equations, then you'll see that you are going to have your different M's and you'll be able to substitute them correctly. But that's not what we're doing because the memorandum is not giving us that. Let's work with what we're given. Then I'm going to look at the MH. Then where do I get the MH? I must go back to my statement. The statement here told me that I've got a mass of 8.5 kg lying stationary on a rough horizontal plate and is connected to a mass of a hanger by means of a light extensive string passing over a frictionless pulley. And shown in the diagram below, mass pieces are added to the mass hanger and the acceleration of the crate is measured. The experiment is repeated several times by adding different masses to increase the hanging mass of each time. Hey, here we're given that the mass is 4.2, but in the statement we don't have. Where do we get that from? We're told again, further they said the result obtained of whatever that took place here were used to draw the sketched graph below, which is this one. The initial mass is 4.2, and as they continually repeat this experiment and add those masses on this mass hanger, then they are going to have the 7.4 at this point. Therefore, we know the mass of this only is going to be the 4.2. Then we can substitute. Again, I didn't substitute here. They don't substitute there. Yes, Kanile, I've noted you. Can I just finish this? Then instead of substituting here, we use our grade 9 mathematics to make T the subject of the formula. Then we substitute. Again, from my point of view, it would have been nice to have the units substituted. I know the guideline says put the units right at the end, but it will be nice to have the units there because I'm going to have the kilograms multiplied by meters per second squared. Then I know from the definition of Newton's second law, the units thereof of kilograms meters per second squared is actually the newtons. And I'm confident that I've done everything right. Then this is newtons. I'm happy. Yes, Kanye?
So there's a TK is saying all upward forces will be equal to all downward forces. Is that correct?
It says what?
He's saying that all upwards forces will be equal to all downward forces.
Oh, so all upward forces will be equal to the downward forces. It will be incorrect to say all.
Okay.
It will be incorrect to say all, but in this, you look at the figure that you are working with. Because in this instance, there are diagrams where you're going to have you'll see, let me put it this way. The next question, we're going to see that we've got the horizontal and we've got an incline in the same statement, and that this conclusion might be incorrect. So let's put it this way. In the particular object that you're looking at, equate the forces that are going to be equal. For instance, if I look at this here that I've shown here, I'm looking at this crate. And from this crate, I've got the normal force and the weight. But if you look at the mass, it also says you've got the tension and the weight. So it gives a wrong impression because of this diagram here, which might not be correct in all the diagrams. So I wouldn't take that to be a nice conclusion to use. Look at the diagram and what is in front of you, then make a conclusion based on that. TK, are you answered? Can we use the F max equals to the coefficient instead of M net, MA? Yes, but it depends on your understanding. Then let's go to that one. We'll go to it in the next one where you want to use that. But remember, before you get to that, you would have done so many things that I will give you marks. If you look at the crate here, with the crate, they say easily, any of this will give you the marks. So what Pillay has shown, he wanted to use the last option, which talks to him because he understands that one better. But remember again, Pillay, the starting point is Newton's second law before you even get to that. That's what is going to give you an answer to that. Then the other one will say, I've got the T minus this based on the diagram equals to MA, but I know the A is equals to 0 because it's stationary. Therefore, I'm going to have the T equals to F max. But again, the T is equals to this because I know the F static max is equals to mu Sn. Therefore, I can write that as the static equals to mu Sn. Then I can substitute. What I don't like about this is that they don't do what they've done here, where they made the T the subject of the formula. I will prefer to make mu S the subject of the formula before I even worry about the substitution. But it does not change the color of a cheese. You're still going to get the same mark. So play your role in your own understanding to make sure that you get the marks that you want. And again, if you put the units, you'll see that your units will cancel out and you are going to remain with this static coefficient of friction without the units. And you'll be confident that you got the correct answer too, because the units are playing that role. What about using option 2? Option 2 here is nice and tricky. Again, it wants us to go back to the diagram. What do we know from the diagram? From what you have drawn, you've got the static friction in that direction. You've got a tension. Now you've got another tension there for that hanging object and the weight of that object. What do we know? The tension here and the tension there is the same. So this static friction and the tension are equal. Noted, Koketo. Then is equals to the weight of the hanging object. Therefore, you can write this static friction equals to the tension, which is also equals to the hanging weight. Therefore, then we say, based on that, we can write any of this four here that is going to give you the marks. And you'll see that the last one there is what Tapile was talking about and is the same as the one that we got on option 1 on the crate. Then you can calculate again, getting the same answer that you got on this one, which is 0.49. Okay, so Huma. Okay, so unmute. Okay.
Yeah, so my question is, I was trying to validate something here. So,
Yeah.
My question is, the acceleration becomes zero when the
Yes.
object is and when the object is also moving at a constant velocity.
Remember, we're talking about the static friction. Static friction means what in terms of this object? And what we are told is lying stationary. So because it's stationary, its acceleration will be equal to 0 because there's no velocity. You can go back to that first problem that we answered in the multiple choice.
Okay, thank you.
You got it? Cool. Are we happy with these two options? Then let's go to the next one. The next question is the magnitude of acceleration represented by y on the graph if the coefficient of kinetic friction between the crate and the table is 0.04. Now, what do we have here is the kinetic friction. The previous one, what is it that we calculated? The static friction, because it was static and we defined the static friction as the tendency of opposing the motion of that object. Now, to get this one correct, Tombi is asking about the break. Yes, we can see if we cannot give a 2 minutes break. Let's just finish this question first. And from here, we can give a break. And there's a lot of questions that we must do, so the break might also be a challenge. Then this one here, again, we draw the free body diagram. Now we're told that this is now moving because we are told we've got the coefficient of kinetic friction. By virtue of that, now our A is not going to be equals to the 0. Okay, so it's not going to be 0 because this object now is in motion. But again, this here, the F net equals to that, the F net on what? On the crate. What do we have on that? We've got the T and minus Fk. Yes, can you see? I've seen that question. I'll come back to it soon. T minus Fk equals to Ma, or Fk minus T equals to Ma. I still have a problem with giving marks for all this, unless we look at the physics, and because these are vectors, we look at them in terms of drawing our Cartesian plane correctly there, so that our acceleration will be exactly what is related to what we have written there. For instance, here we say the T minus Fk equals to Ma. This object will be moving in that direction. I'm happy with that statement. The Fk minus T equals to Ma. I've got a problem with that statement. Because if this object has the positive Fk and the positive A, it means it's accelerating in the direction of that. So it must be a negative. I don't know why the examiner here is not taking care of that, but is what it is. I'm going to just give you the way of thinking out of how to write this so that you don't make mistakes, because this will make it a problem for us to get the correct answer if we take either off and we don't have them the same way. Okay, let's see. What is the difference between moving at a constant velocity and moving at a constant acceleration? The starting point, constant velocity, there's no acceleration. That's number one. Oh, TK is answering here. All I know is that when it's a constant velocity, the object accelerating. Okay, we'll come to that. But when it's not moving at a constant velocity, the acceleration is zero. It's sometimes they're very tricky. This question is nice and tricky. Mr. Kwanda, you want to come in?
Yes. Hello, guys. I want to respond to the difference between a constant velocity and a constant acceleration. When velocity is constant, the acceleration is equal to zero. When acceleration is constant, the velocity will be changing. I don't know if you are clear with that one.
Okay, Mr. Kwanda is taking us to the definition that we gave earlier on of gravitational acceleration, where we said the gravitational acceleration is equals to 9.8 meters per second. Per second, we said there is a change in the velocity, but that velocity is changing constantly. So that's what it said. And the constant velocity, it means the object is traveling with the same velocity. It's not changing with the constant velocity. So there is a difference between the two. Be careful, look at the statement. If the statement says changing with the constant velocity, then it means you've got the velocity that is changing constantly with the same magnitude in every second. But if the object is traveling at a constant velocity, it means that object has only one velocity. The initial and the final velocities are the same. But if it's a change, it means the first one, the first second, in the example that we gave earlier on, at the first second, that object that was thrown downward will have the 9.8 meters per second. The second one, it would have changed by the same amount, so that means it's going to be 9.8 plus 9.8. The third one, we're going to add the 9.8 on that one, that is going to give you how it's constantly changing. I guess I've answered that question now. We are all sorted. Kamuhelos, I'm really confused. Why aren't we using the tension force that we got from the previous question to find acceleration? Okay. Let's look at that and why we can't just simply use that tension. Let's go back to that question that you are referring to for a second. What was the tension that you got here? You had the static friction. That's number one. You didn't calculate the T, but you then use the T to say T is equals to this. And again, the T is equals to mu. Then you equated the two to give you that. So if you're using the simultaneous equations, you would have got your T's cancelling out. Kamuhelo, the T's would have cancelled out if you use the mathematics. That is why it's so nice to know the link between the physics and the mathematics and where they can help you. If you use the simultaneous equation, you wouldn't ask that question. But because you use this method thinking that I calculated T here, which is this 41.146, I'm going to use it again. Avoid using that. Then I'm avoiding to use that because I can play around with my mathematics. And I say here, if I've got this with the mu k being 0.4 and the mass of the crate. Remember I said write the mass of the crate so that you are not confused. You know what is the mass of the crate is 8.5. And you come down here, then the confusion starts. 7.4. Why 7.4? What is the question that am I asked? They said here, I must calculate the magnitude of acceleration represented by the y on the graph if the coefficient of kinetic friction between the crate and the table is this. So this is the mass in this graph that I'm given, which is 7.4. Hence, I needed to have this as mass of the hanging. After I've repeated, according to the statement, this has been repeated. Therefore, this one then is going to give you that. Equation 2 says then I'm going to have the 7.4 and make y the subject of the formula from this, which is equals to the a. This is what they're asking us. Y is our acceleration. Then you get to our a to be the 2.4 meters per second squared. And t can be calculated first to be that. Again, it goes back to show you that is not what Kamuhelo was asking, is a different problem altogether, because this is now in motion. I hope that question has been answered now. We are all clear. Then let's try the last one. It says a 5 kg block is now placed inside the crate and the experiment is repeated. How will this affect the maximum static friction force now experienced by the crate? Can you write your answers quickly on the chat and let's see which ones are going to get the correct answer? Quickly. Let's get that and see. And remember, as you choose either the increasing, decreasing, or remains the same, you must give reasons to that. Please choose and give us the reason. Yeah. This is what I checked. Okay, let's see then the answers that were given here. None. Hey, oh, they're there. Can I unmute and answer? Say, yeah, let's try that one. One says increases because the static friction has stopped to oppose more weight. Wow, interesting. Increasing as the weight of the object increases, the gravitational force increases, resulting in an increase in the static friction. Wow, interesting. Yeah, Zoom user, do likewise quickly. Let's hear you. Unmute quickly and give us an answer. Okay, the person cannot unmute. It's fine. Yes, those that said increase, that's correct. You increase the maximum static friction because now your normal will go, your normal is going to increase because as you put more weight on top of that, the friction is going to be maximum. And one reason that then another person can give is that normal force acting on a crate increases. By increasing the mass, the weight of the mass is also going to be increasing, which makes the normal force to increase. There's a different question altogether. In a multiple choice, you can get this, and we can ask you to draw or show with the drawing of the free body diagram what you are getting. Then this leads us to the next question. And maybe let's do this question. Let's take a 3 minutes break to get some water and come back quickly to do this question. We'll try to do question number 3. And after question number 3, we'll take the second part of this, go to electricity, and see how many questions we can do there. Then come back to this part of the mechanics. We are trying to make sure that we balance. We have all the questions tried from all the angles. And we'll still have to do the momentum. We're still going to do the drawing of free body diagrams again. But because we've touched on that, maybe it will be important of us to go to the electricity question and come back to this again. Can we say that the static friction is directly proportional to Fg? No. Hey, that one will be dangerous. But remember, as you increase the weight, then you are making the static friction to be increased. But to say directly proportional, it will be very dangerous. The normal force will increase when the mass increases. This one I'll take. Oh, TK says, let's do electricity. Yes, we're going to do that. Static friction needs to increase to stop the object from moving. Yes, I'll take that one. So let's take that 3 minutes break. And from there, we'll tackle the electricity problems, and we'll still have to come back when time allows. So we have done the preparation. So we still need the projectile motion, momentum, energy. We'll come back to those, work energy application. Then we'll start here, and I'll give Mr. Kwanda then to tackle these questions, and we will then resurface immediately after that. So the 3 minutes is gone. For those of us that were taking water, that ran to the bathroom, I hope we are all back. And then let's see the chat. What time are we coming back? You are late. The 3 minutes is gone. Let's just add 1 more minute to accommodate that those didn't get the time. Guys, we've got an hour that we have spent. If we are left with 2 hours and we still have more questions to do. So unfortunately, more breaks cannot be given. We can just navigate within. And then I'm giving over now to Mr. Kwanda to do the trick. Over to you, Mr. Kwanda.
Okay, thank you. Thank you. So, good morning, guys. So, we'll be starting with electricity. I hope you are seeing the question on the screen. Oh, okay. Okay, this will change. You go. Move this towards the left. Move it to the left, then it appears there. Move it back, right, so it's this and that. Okay, no, thank you. So this is also a multiple choice questions. I think my colleague has already indicated exactly how to answer multiple choice questions. I think another thing that is very, very important, once you have a question, you should ask yourself, which section in physics can help you to answer what? That question. So in this one, you have the 2 objects, mass 1, 2 mass, and 2 charges. They are separated by what? By distance r. So the question says 2 small identical spheres, each with mass m and the charge plus q, are placed in a vertical cylinder. The sphere remains stationary when their centers are r meters apart, as shown in the diagram. Ignore all frictional effects. Which one of the following expression can be correctly calculate what? The distance r. So you can see that the question is having what? The charges, and there's also what? Masses. So it means that if you go to which section of physics you can be able to answer, you will find that somewhere, somehow, mechanics can also help, Newton's law of universal gravitation, and also electrostatics, which is what? Coulomb's law. So, but when you check more on what, on the equations, on the answers, you can see that there's Fg. So then you have to ask yourself, where is that Fg coming from? So I already indicated that from Coulomb's law, you have this equation. F is equal to KQ1 Q2 over R squared. That is equation from Coulomb's law. But from mechanics, again, you have F is equal to what? Mg. So then we can make that F to be equal to Mg on the what? On Coulomb's law. Then after that, we can make R the subject of the formula. So if you make R the subject of the formula, what do you get? Which option do you think is the most appropriate? Can you just write on the what on the chart? You just write A, B, C, or D so that we can see exactly which one do you think. I'm giving 1 minute to make what? R the subject so that you can. So the majority of you are saying A. There is no one who's not saying A. So so the majority of you are saying A. Let us check if A is the most appropriate answer. What happened? Okay, so A is the most appropriate answer. Thank you. You got it well. It means that all of you are able to make R the subject of the formula. You are able to apply your mathematical skills.
And maybe just to come in there, Mr. Kwanda, the guideline says in many cases, it gives an impression that you must simply substitute your constant, your Q and R. But then we can see from this question that is not necessarily correct to say just substitute there. You can still make R the subject of the formula. And that skill helped you to now answer this question that could have been complicated to answer. Then in terms of substituting, once you have done this exercise and you made R the subject of the formula, in a different question, if you're given the values and you're asked to calculate the R, it would be easy to calculate R based on this option that you would have came up with. Thanks, Dr. Kwanda.
Okay, thank you. Now, the next question is about the definition. The kilowatt hour is a unit of. So I think my colleague indicated that you must be able to know how to define everything in what? In physics. The definition will act as what? As a key. So before you can answer this question, the most important thing is to know how to define each term and write the SI unit. So when you define and write the SI unit, you'll be able to eliminate the answer that is not correct. So let us check in terms of this one. Which one do you think is the most appropriate answer for this question? So I want you to choose before we can discuss. You can write those things on the chat box. I want you to choose before we can discuss. Can you choose the most appropriate answer? The kilowatt hour is the unit of, is it a unit of power? Is it a unit of electric current? Is it a unit of electrical energy? Is it a unit of potential difference? So I'm getting C, another one is saying A is power. So there is a C, there is a A. I think most of you are what? Are writing either C or what? Or A. So let us go back to the question. So I said you must be able to define power. So let us start by defining power. Power is normally defined as the rate at which energy is transferred is defined as the rate at which work is done. So that is power. So the SI unit of power is watt. So let us come to electric current, the rate at which charges are flowing, and the SI unit of electric current is ampere. So electrical energy, so this one, let us keep it for now, then we go back to what? To potential difference. Potential difference is defined as what? Work done per coulomb to move a charge from one point to another. So if you look at both A, B, and D, so the units is not what? Kilowatt hour. So then it means that the most appropriate one will be what? Electrical energy. So why electrical energy is what is rated as kilowatt hour? So kilowatt hour generally is used instead of joules for measuring what electrical energy consumptions, because joule is a very small unit, making the number for everyday usage inconveniently what? Very, very large. So in order to prevent that, it was agreed that kilowatt hours will be used in measuring what? Electrical what? Energy consumption. So the most appropriate answer now for this one is C. The kilowatt hour provides a more practical, intuitive, and easily understandable unit for consumers and utilities to express energy use over common what? Time frames. So you understand that if you use electricity for a short time, so the energy that is going to be consumed will be less. But if you use more, then you will have more. So the next question, I don't know if there's any question concerning this one. If you have a question, you can write those questions on a chat board. I'll give you 1 minute too. So any question you can quickly write. So the unit for power is what? At least in norm level answered the question. That is correct. The unit for power is what? So say what is the unit of power is what? The formula, this one who wrote power is equal to W over T. I'm thinking that W is work done. Power is defined as the rate at which work is done. And its unit is what? Is what? Okay, we can proceed to the next question. So again, the diagram shows simplified electric motor. The rotation of the coil is observed from the battery. Which one of the following statements is correct while the motor is in what? In operation. As we indicated before, we said we should identify exactly where is this section in physical sciences or in physics. So after that, then you'll be able what? To answer the question. So the diagram is electric motor. Electric motor is having what we call a magnet, a coil, and the commutators. So this motor, based on the diagram, is a DC motor because we can be able to see what the battery terminals. So in order for motor to rotate, there is a law that can help us to predict the direction in which it's going to rotate. So before you answer this question, you should understand exactly how a motor works. A motor works using what? The force exerted on the current carrying conductor when it is placed in what? In a magnetic field. So current carrying conductor will have what? Magnet around what? Around it, and that magnetic field will what? Will interact with what? The magnetic field of the magnet. And when they are interacting, that's where they will cause the force to tend to what? To move the coil. So the direction in which it can move can be found using what we call what? the right hand rule. The force causes the wire, the coil to rotate, creating the movement that makes the motor to work. So you must be able to know how to use the right hand rule. So to review, there is two ways of dealing with the right hand rule. On the left hand side, your fingers is representing the direction of the magnetic field, and the current is indicated by what? By your thumb. So then at the center of your hand, it will indicate what? The direction of what? Of the magnetic force. So then what you are supposed to do, you have to align your hand indicating those direction. For example, magnetic field in the magnet, is directed from what? From the north pole to our what? To the south pole. Okay. The right hand rule again, on the right hand side, your forefinger will indicate the direction of magnetic field. Second finger will indicate the direction of the current. The thumb will indicate the direction of the force. So you can choose which one to use. They will all give you what? The same. When you apply all of them, you'll get what? The same answers. Okay. Okay, what was the question? For DC motor, do you use the left-hand rule, while for generator, do you use what? Where is it? Okay, can you please give us a AC generator and a DC generator? DC generator, okay, they are confusing me and so on. I don't have the answer. Okay, so when we say AC generator, now we're moving from motors. It's a new topic altogether. So, but I can tell you the difference between a motor and what? And a generator. In a motor, there must be a source of what? Like a battery or like a battery. So that source should help what? The motor in order what? To turn. So then the coil will be turned when you supply what? When the battery is connected to it. But when you deal with a generator now you're generating what? Current. You're generating current. So then it means that you have to turn the coil in order to what? To generate what? The current. So, but in a motor, you supply what? You connect with the battery so that the coil can turn. But in a generator, the coil, you turn it yourself, or there must be various ways in order what? To turn the coil so that electricity can what? Can be generated. So when we said AC motor, we're saying that that motor is connected to the AC alternate current. When you say DC motor, that motor is connected what? To the direct current. So slip rings rotate. So let us first continue, then we'll come back to some of the questions later. Where do I go then? Okay, so before answering these questions, it is very, very important to know how to label what? The diagrams. You should be able to know how to label the diagrams. There is a coil, there is a commutator, there is the battery, there is a magnet. You must be able to know what is that and the role of each on the diagram. So they talk about commutator. What is that thing we call the commutator? A commutator is a rotary electrical switch in certain types of electric motors and electric generator that periodically reverses what? The direction. So if we look, so if you look this side, you can see that this is the part that will rotate. And when it rotates, it will be changing what? The direction, because this side is positive, this side is negative. So when this one rotates anti-clockwise, it will come to this side, and this one will come to that other side. So then when it is the motor is moving So then the directions or the poles will keep on what? On changing. So that's what we call a commutator. So the enlarged diagram of the commutator is the one on the right-hand side. You must be able to know how to do what? How to label the diagram. So there are brushes. Normally, they are for contact. These are carbon brushes. They are only made for contact so that when you connect to the batteries, the current should go through from positive terminal, and then it goes that side, then it turns. But it will, because of the commutator, it will keep on what? Rotating or changing direction. And when it changes direction, it's also changing what? The strength of what? Of magnetic field. It will keep on changing. And when it's keeping on changing, then that will result in what? In the force that will continuously rotate what? Rotate the motor. So if we look at this one, which one do you think will be the most appropriate answer? So you should use what? The right-hand rule in order to do what? To predict. So you align your what? Your right hand magnetic field should be directed from right what? From north to south. And then the current in the coil should be directed from what? You use the direction of what? Of the battery should be directed in the. So can I put this one? So on the coil, the current is directed what? Up. Then this side it will be coming down. So then your thumb will indicate the direction of what? Of the force. So then if you use that right hand rule, you can choose the left one, the left diagram or the right diagram. Which one do you think will be what? The most appropriate answer? When you use what? Your right hand rule. Which one do you think it will be the most appropriate answer? So in terms of the choices, they said which one of the following statement is correct while the motor is in what? In operation. So the coil and the slip rings rotate anti-clockwise. The slip rings rotate clockwise. The commutator rotate clockwise. The commutator rotate anti-clockwise. These are the forward options. So then if you look at these diagrams and so on, can you see the slip rings? Can you see the commutator? So this will help you in order to do what? To do the elimination. So I'm giving you 1 minute to use your hands and to predict which one do you think will be the most appropriate answer. Okay, I'm saying C, D, C, C, D, final. I hope you are using your right-hand rule in order to predict the direction in which the commutator will take. So there is no other answers. I think it's like most of you are eliminating option A and B. Maybe you know the reason why you're eliminating them. Okay, let us go back to the answer again. So I hope you have labeled the diagram. You use your right hand, then the most appropriate answer is D. Most of you opted for C and D, but the most appropriate one word is D. So then we can move over to electric circuit. So something to note when dealing with electric circuit. Okay, Kanye, can you ask the question, please? Kanye?
Oh, how you got D incorrect?
Mm.
You say, how did you get? Can you explain how you got D incorrect?
Okay, so can you hear me?
Yes, I can hear you.
So the students on YouTube, they're asking if you can see their questions and their replies there.
In YouTube, no.
Oh, okay. So they're asking about the motors if you're not using left hand rule. So that's the common question that I'm asking.
So whatever rule you can use, as long as you use correctly, it will give you the same answer. Whatever rule that you can use, if you use it correctly, the answer will be the same. So, okay. I can, Kukeso?
Yes, on the previous question, you said that we had a battery. So when we are given a battery, can we always assume that the current always moves from the positive terminal to a negative terminal?
Yeah, according to the conventional direction of current is directed from positive terminal towards what? The negative terminal. So it's only that the commutator that side, it will keep on reversing, but from the battery, it will always be the same.
Okay, thank you, sir.
Okay. Okay. Electric circuit. So the most important thing that you should know about electric circuit is to know the definition and the role of each circuit element. In an electric circuit, there is a battery, there is a resistors, there are conductors, there are switches. So then you must be able to know what is a switch, what is a battery, and what is its role in electric circuit. So these are what we call the physical components of what? Of electric circuits that you can see. After knowing the role of those things that you can see, then we get deeper to the conceptual what? Terms. So in electric circuit, we have EMF, we have resistance, we have current, we have potential difference. So it is very, very important to know the definitions of those. It is very, very important to know the definition of both. And again, you must be able to know what we call the global impact of electric circuit elements. So the global impact simply means that once you change or you change the value of each circuit element, that change will affect the whole circuit. Changing, for example, changing the magnitude of L2, it will change everything. It will change, let's say we're changing the resistance of L2. Changing the resistance of L2 will have the impact on the current, will have the impact on the total resistance of the circuit, will have the impact on the what? On the potential difference. So that is very, very important to note that all the time, once you change any circuit element, then everything is going to change. So in our diagram, we're given L1, L2 as two light bulbs that have the following ratings. L1, 36 watt and 20 volts. L2, 48 watts and 32 watt volts. So normally when you go to shop, when you want to buy the bulb, it will have its own rating. They are there before. So the two bulbs are connected as shown in the circuit diagram below. The battery has an internal resistance of 0.6 while conducting wires, and the ammeters have negligible resistance. R1 and R2 are resistors. The This is explaining what is on the diagram. So bulb L1 bends out after a while. Assume that the resistance of bulb L2 remains constant. Now the question is, what do you think will happen to the total resistance of the circuit, to the total current of the circuit, and the potential difference of the circuit? What do you think will happen? So we can start with what? With the total resistance of the circuit. If bulb 1 bends out, what do you think will happen to the total resistance of the circuit? Is it going to increase or is it going to decrease? So you can just write either increase, decrease, or what remains what? The same. You can just write what? Increase, decrease, or what? Remain the same. Can you write quickly right now? Let us see. Increase, decrease, or remain the same. The resistance of external circuit will increase, increase, increase. So there is no one who's talking about what? Decreasing. So the question is, what do you think will happen to the whole circuit in terms of resistance, current, and potential difference? I said we should start with the total resistance of the circuit. I think most of you have already indicated that the total resistance of the circuit is going to increase. So that's what we said earlier when I say what? Changing one thing in the whole circuit will have the impact on the what? On the whole circuit. So they said L1 bends out. L1's bend out. It means that now we're left with how many resistance? There will be R2 and what? And R1 and L1. So then once you take off L1, so then you are left with what? With R2, L2, and so on. So then the total resistance of the circuit, even when the resistance of L1 has been what? Taken out, the total resistance of the circuit will increase. Those who said increase, I think they have chosen that is the correct answer. The total resistance of the circuit will increase. So now the second question will be, what will happen to the total current of the circuit when the total resistance of the circuit is increasing? So then you can quickly write, now we're answering the one in terms of current. Do you think the current will remain the same? Do you think the current will increase? Do you think the current will decrease? So you can quickly write those ones. So I already have decrease, 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 decrease. There is no one who's saying the total current will increase. So lastly, what will happen to the potential difference? Generally, potential difference is work done per coulomb to move a charge from one point to another. So do you think the work done will be more? Will it be less in order to move a charge from one point to another? So now, lastly, let's answer the last question. What will happen to the potential difference? You can quickly write the potential difference will increase, remain the same. Potential difference remains the same. Increase, remain the same. What about others? Current will decrease due to increase in the total external. Now we're dealing with what? What will happen to the potential difference when L1 bends out? What will happen to potential difference when L1 bends out? Yeah, you can ask. Hello, can you?
Okay, so there's a question on YouTube by Mashakeni. He or she is asking, how do you calculate internal resistance?
To calculate internal resistance, I think we will deal with it. We're coming to it because it forms part and parcel of what of the whole circuit. You should understand everything. EMF is equal to lost volt plus terminal potential difference. Then we're going to come with that one. So, but the general idea, it starts from there. EMF is equal to lost volt plus terminal potential difference. In a lost volts, that's where you have small letter r, which is for internal resistance. When you make that r the subject, then you can be able what to calculate it, but we'll come to it. So we already answered the global question. The global question, it was talking about the impact of changing one circuit element will have the impact in the total what? In the whole circuit. So in the potential difference, what is going to work done, the many people were saying potential difference will remain the same, potential difference will what? Will decrease. Is it true? So if we define potential difference as the work that is done to move a charge from one point to another, when the total resistance is high, what do you think will be the work to be done to move that charge from one point to another? So it means that more work needs to be done per coulomb to move the charge from one point to another when the total resistance is what? Is increasing. So then the most appropriate answer will be what? The potential difference will increase because more work has to be done in order to move a charge when the resistance is what? The total resistance is what? Is high. More work needs to be done because there will be more resistance. So the next question, will L2 continue to glow after bulb L1 burns out? You either choose yes or what? Or no. But this one, we are going to answer it later because it will need you to first deal with what? With the calculations that are coming. So then we'll answer this one later. It is very, very important question because you will have to, when answering it, you will have to check what? The ratings, L1, 36 watts, L2, 48 watts, and so on. In your calculations, they will help you what? To answer that question. But we're going to come back to it later. So what we were doing before, we're trying to answer those questions conceptually without dealing with any formula, any calculations. So now we want to confirm what we've been doing, if it will be consistent with what? With our calculations. Again, you remember previously, I said there was a multiple choice question that was having what? Power. I said you must be able what? To define what? Power. We already defined it as what? The rate at which energy is transferred or the rate at which what? Work is done is what? Is power, and its unit is what? Is watt. You can see L1 is having 36 watt. That is its power rating. L2, 48 watt. That is its power rating. So the rate at which work is done dissipated or energy transferred or work done per unit time is what we call power. So what is in red are what we call keywords. So it means that you can define it using your own way, but the keywords should be there. Keywords should be there. The rate at which work is done or energy is transferred or work done per unit time. So these are the keywords that should be used when you define what? Power. So 8.2, it says, if both light bulbs operate as rated, calculate the reading on A2. You can see where A2 is. Is that okay? So after 4R, so then the circuit branches, there is L1 and what? L2. And then again, it combines to give you what? A1. So you must be able to know exactly what happens when resistors are connected in series, what happens when they are connected in parallel, what happens when you remove one of the resistor. As we indicated before, the impact of changing one circuit element will be what? Will be global. So it means that it will affect everything in the circuit. So they said calculate the reading on what? A2. You have been given what? L2. The power in L2 is what? Is 48 watts. So, but you should be able to know what? The formula to calculate power. Is that okay? They want you to calculate what? The current. So then one of the formula to calculate power is power is equal to IV. Power is equal to IV. So from that, it was just a direct substitution. You were given what? Power. You were given what? Potential difference. So just direct substitution, then you should get your current to be what? 1,5 amp. Just direct substitution, you will get your current to be 1,5 amp. So then there is a question number 2. 8.2.2, calculate the reading on what? A1. Ask yourself, what is A1? A1 is representing the total current in the circuit. And in order to determine the total current in the circuit, there are various ways that you can use. Sometimes you should also know the current through L1. So you should know the current through L1, because if you say the current through L1 plus the A2, they will give you what? The current through what? A1, which is the total current of the circuit. So then where do we start? We can also, in R1 we don't know. There is a resistor which we don't know what? Its value. So we can first, by calculating what? The resistance of what? Of R1. If you calculate the resistance of R1, then it will be easier for us to calculate the current through what? That resistor. Once we know the current through that resistor, it means that we are going to add A2 plus current through R1. They will give you the total current of the circuit, which is A1. So let us get into how it was what? Calculated. The resistance of R, it was what? It was easier to calculate. You just use what? The formula. I think this formula, P is equal to V squared over R. You will find it in the formula sheet. Then you just substitute, then you get R1. If R is equal to 21,33, then you can substitute. You can use either V is equal to IR or what? P is equal to what? I squared R. Those formulas, you can find them on the what? On the formula sheet. So then you are finding what? I to be what? 1,5. 1,5 amp, 1,5 amp. So then it means that if this one is 1,5, hence, now if this is 1,5, you already calculated this one to be what? 1,5. So then it means that what? The total current A1 will be the current A2 plus the current through R1. That will give you what? The total current of the circuit, which gives us what? It must be 3 amperes. So the next one, calculate the I total. Here we go to 1.8. How do you get to option 1, 1,8? Okay. For L1, power is equal to VI, then 36 is equal to 20, which is, hello?
Sir, I have a question, sir.
Okay, you can ask.
Why are we using L2 the power for L2 and the voltage for L2 to calculate R1.
Can you repeat?
Isn't it in the previous question you were using L2 to calculate for R1?
Let me go back.
Yeah.
So which one?
You used
L2.
you used the information they gave us for L2 to calculate for R1.
Yeah, it must be a mistake, because R1 we should use the information for L1.
Yeah. So I think there was a mistake over there.
Yeah, if that is the case, let me quickly check.
Okay, sir.
48 is L2. And okay, this was the first part to calculate the current through A2. The one that is A2 is 1.5 amp. Is that okay?
Okay.
So then, when we go to 48, okay, okay, so sorry, what I made a mistake here. This is also the second option to calculate what? A2. The first option was you can use P is equal to VI. The second option, you calculate the resistance, then you call. All of them will give you 1.5.
Oh, okay, I understand.
Yeah, sorry, I forgot. This one, this is the first option of calculating it. This is what? The second option. So there are various ways in which what you can use in order to answer that question.
All right, sir.
Okay, is it making sense now?
Yes.
Okay, no, thank you. So let us go to L1 now. For L1, you have 36. That is the power that is given. You have 20. That is current. So if you make I the subject, you get the current to be 1.8. The current is 1.8. So on the right-hand side also is option 2. It is giving us what? 1.8. So the most important thing is when okay, thank you. So the most important thing is the current through R1 and the current through A2 must be equal to what? The total current of the circuit. So we calculated the current through A2 to be 1.5 and the current through R1 to be 1.8. So when you add them, they will give you what? 3.3. So the total current of the circuit is 3.3 amp. So let us go to the next question. Calculate the resistance of a resistor R1. So R1 is in parallel with what? It's in parallel with what? With L2 and A2. So hence, VR1, there is potential difference across R1 plus potential difference across the parallel circuit. Then when you add them, you will get what? So the resistance of R1, VR1 plus VL1 must be equal to what? V parallel. So why is it V parallel? Because in parallel circuit, the potential difference is the same. Parallel circuit, the potential difference is what? Is the same. You have been given what? L2 to be what? To be 32 volt. So if L2 is 32 volts, then it's V parallel. So then when you add them, L1 and plus L2 should give you what the total potential difference of the parallel what combination. After getting the total potential difference for the parallel combination, that's when you can be able what to calculate R1. So using Ohm's law, V is equal to what? IR. So you have 12, you have current, the total current through the circuit is what? Is through the parallel, through L1 is equal to what? 1.8. We already calculated that side. Then making R1 the subject, you'll get what? 6.7. R1 the subject, you'll get what? 6.7. So on the right-hand side is another way of doing it. There are various ways of, so there are many options. So then you choose the one that what you think you understand. But this one, the most important thing is, the key thing is what? When resistors are connected in parallel, the potential difference will be the same. That is the key that can help you to answer that question. So we have, now I hope you have the values. So then we go back to the previous question. The previous question was bulb L1 bends out after a while. Assume the resistance of L2 remains constant. Will light bulb L2 continue to glow? L1 is out. Do you think L2 will continue to glow? So then you should choose either. Hello? Is there any question?
Say you skipped 8.2.4.
Oh, okay. So what is the total EMF of what? Of the battery. So how do we get the total EMF of the battery? In order to get the total EMF of the battery, then you can do the following. Write the equation. EMF is equal to lost volts plus terminal potential difference. Write that one. EMF is equal to lost volts plus terminal potential difference. So the second stage now, you should substitute. Instead of lost volts, write I small letter r. Instead of terminal potential difference, write I R total. So after writing those, you must be able to calculate the total resistance of the circuit. If you have calculated the total resistance of the circuit, then you substitute. You know the total current of the circuit. We already calculated it to be 3.3. What we didn't calculate is what? Is the total resistance of the circuit. The total resistance of the circuit, it talks about R1, L1, the resistance through L1, resistance through L2. These are the ones in parallel. You can use that formula for parallel section. After that, you will say R parallel plus R2. That will give you what? The total resistance of the circuit. Once you have the total resistance of the circuit, current will be the same. It will be the total current of the circuit. Internal resistance, you have it, small letter r. Then once you substitute, you will get the EMF. Once you substitute, you will get the EMF. Yeah, I'm seeing is TK. I use the equation EMF equal to I R external plus R internal. Is the same thing. R external is the terminal potential difference. Is the resistance, total resistance of the external circuit, and the R internal. Well, I think it will give you the same answer. So lost volts is the potential lost due to the internal resistance of the battery. Normally, when the battery is working, it becomes hot one way or another. So then there will be what you call what? Lost volts. The difference between EMF and the terminal potential difference is also referred to as lost volts. Where is it? Where is it? Okay. Oh, Naledi, can you talk, if possible? Naledi, can you talk?
Can you hear me?
Yes, thank you.
Yes, I wanted to ask, may you please repeat what the lost volts are?
Okay. So the battery is having what we call internal resistance. When the battery is, when the circuit is off, when you connect the voltmeter across the battery, you will get what we call an EMF. An EMF is usually read when what? When the switch is off. It's not, the battery is not connected to anything. You connect through the voltmeter. So once you connect the switch to be on, if the voltmeter, the same voltmeter that is connected across the battery, it will go down. When it goes down, it will read what we call potential difference. It will no longer be EMF. That value will be down. So the difference between EMF and the potential difference of the circuit is what we refer to as what? The lost volts.
Lost volts, okay.
When the switch is on, the battery will read EMF. When the switch is off, the battery will read what? Sorry, when the switch is on, the battery will read potential difference. When the switch is off, the battery will read what? EMF. So those two values will be different. EMF will be greater than what? Potential difference. The difference between the two is what we refer to as what? As lost volts.
Okay, thank you.
So in general, EMF is equal to lost volts plus terminal potential difference.
Okay.
Okay, thank you. Okay. So the last question. It was, will light bulb L2 continue to glow after bulb L1 burns out? Choose from yes or no and support your answer with what? Calculations. If we look, the most appropriate answer is what? Is no through calculations. If they didn't ask, they didn't give you the ratings, you might say bulb 2 will continue to glow if L1 burns out. But they gave you what? The power rating. The power rating is to check, will the current through L2 be enough to what? To make the bulb L2 to glow. So calculating the current, we find that the current should be what? 1,82. The current through L2 for it to what? To glow. But previously, when we calculate, we find that the current through that one was what? Was 1,8. I think it was 1,8 what? Let me quickly. Let me quickly go back. The current was 1,8. So now we need what? 1,82. Because we need 1,82, it simply means what? It cannot what? So. It simply means that bulb 2 cannot what? cannot glow because it will need more current. So that's why I'm saying, if you were not given what we call the power ratings, it will be easier for us that, when L1s burn out, there will still be current in what? In L2. Maybe it will glow. But because we are given the power ratings, it cannot glow because the current will be what? Small in order what? To make it what? To glow. So that was the tricky question, that one. Because generally, if you're not given what? The ratings, the answer can be what? Yes, it will glow. But if you're given the power ratings, you should check if there will be enough current what? To pass through that one. So I'm quickly going to what we call, if there is no question, then we can proceed. Okay. So the next question is what we call.
Okay, sir, question, sir, before we proceed.
Okay.
Okay, let's say that there was a voltmeter that was connected on R1. Would the readings on the voltmeter be equal to the EMF, or it's going to be equal to the potential difference?
So now, because there is R2, there is R1. If it's going to R1, it will be potential difference across what? Across R1, not potential difference of the whole circuit.
Oh, okay.
Because
Thank you,
there's
sir.
a potential, when I was talking about EMF and the terminal potential difference is the total potential difference of the whole external circuit.
Okay.
So when you add it with lost volts, that's when you have what? EMF.
EMF. Okay,
Yeah.
thank you, sir.
Okay, thank you. Yeah. So the graph below shows how induced current in a generator varies with what? With time. So before we can even go, that is the first question. Name the type of generator. Do you think the generator is AC or DC? So I would like you to choose and also explain why are you saying it's AC or why are you saying it's DC? Can you quickly write those ones on the chart? So majority are saying DC. What is the main reason for that? Yeah, there's no one who's writing AC. So can I just get an explanation? DC because AC needs to alternate by doing full cycle. Current does not alternate. So we said DC current is in one direction. AC current keeps on changing what? Direction. So current does not alternate. Then if you look on the diagram, yes, the answer should be a DC. So DC, if we're talking about direction, you can see the timeline and the vertical. So there is a 0. So if it was AC, so it means that this graph will also go down to the negative side, go up positive and the negative side. But it's on one side. So it means that it's on the positive side only. That's what we call in one direction. And hence, this is what we call a DC. So most of you get that one correctly. It's DC because current is not alternating. It's in one direction. Okay, sorry. State the energy conversion that takes place in a generator while it is in operation. You remember we talked about a motor. In a motor, we said we should have a battery to cause the commutator to rotate. So in a generator, we have to turn it ourselves, or we have a means of turning it without a battery, because the main intention is to produce what? to produce induced current or induced voltage. So state the energy that is taking place in this generator while it is in operation. So you can quickly write down answers. Mechanical energy to electrical energy, mechanical energy to electrical energy, mechanical energy to electrical energy. So most of you are writing what? Mechanical energy to what? To electrical energy. So indeed, in a generator, you have to turn when you are producing the motion so that we have current. So hence it's mechanical, and the end result is to produce what? Electricity. So then that is through the conversion is from mechanical energy and to what? To electrical energy. The next question, give a reason why a generator is not suitable for transmission electricity over a long distance. Why this generator? We're talking about this generator. This is a DC generator. It cannot be able to what? Reason why the generator is not suitable for what? For transmission of electricity over what? A long distance. Give us the reason why. Can you simply write down the reasons? Why this generator, this DC generator, is not suitable for the transmission of electricity over a long distance. Reasons, guys. Why this generator is not suitable for transmission of electricity over long distances. It cannot minimize energy. It has a split ring commutator. Is because the voltage cannot easily be increased using transformer in large power losses during transmission. So these are some of the answers that some of you gave. So generally, when electricity is distributed from the power station to where it's supposed to be used, there is something which we call a transformer. A transformer at the power station will step up the voltage. When it is stepping up the voltage, it will be reducing what? The current at the same time. So when the current is reduced, so there will be less power loss. When current is reduced, there will be less power loss. So then, when distributed to a place where electricity is supposed to be used, they also put another transformer. A transformer that will be what we call what? A step down transformer. When you step down the transformer, you will be stepping up what? The current, stepping down what? The voltage. So then the DC, it cannot be able to what? To work because the transformer, the changes that usually happen, the rotation, the changes in direction and so on should happen what? Very, very fast. So then it cannot be able to help because of that. So then in order to do the alternate current is the one, AC generator will be the one that can what? That can help to solve what? The problem. So to avoid the power loss, voltage loss cannot be reduced, will be too large, so some of the wires can get bent. So in order to do that, current cannot be made smaller because a transformer cannot work using what? DC. So that is the main reason why DC generator cannot transmit what? Current over a very, very long distance. The next question, we are to calculate the frequency at which the coil rotates in a generator. So before you do the calculation, so in South Africa, you will find that all our appliances will be written at 220 to 240 volts, and there will be a frequency. The frequency that is normally given is 50 hertz, 50 to 60 hertz. So if you check all the appliances and so on, they will be rated 220 volts, 220 or 220 to 240 volts, and the frequency 50 watt to 60 or 50 hertz, and so on. So when they say 50 hertz, it means that it what? It changes the cycles 60 times per watt per second. So now they want you to calculate what? The frequency. In order to calculate the frequency, what are we given on the diagram? What are we given on the diagram? We're given time. Time is the period. So then, what is the period for complete cycle? That is what we call what? A catch. You must be able to see from what? From the diagram. So then, if you have done it well, frequency will be equal to 1 over period. And the period is 0.0 what? 2. So if the period is 0.02, it means that the graph starts to repeat itself after what? After 0.02 what? Seconds. So if you have done well, it gives us what? 50 hertz. That is the frequency of that generator. So the next question.
The question, sir.
Okay.
Sir, I'm confused as to why we're using 0.02 as our period.
Okay. The complete cycle. If you look at this graph, the complete cycle will what? Will happen after what? 0.02 what? Second. The problem is that this one, they use what we call a rectifier so that you only have what? The current only in one direction. But if you draw the full cycle, the sine wave, you'll see, so that it will get down and start to repeat itself what? After 0.02.
Yeah, I now see. Thank you, sir.
Okay, thank you. So the next question, they say the term root mean square current. What does that mean? Root mean square current. So when you say root mean square current, what does that mean? So to give you a background, normally if you look at the bulbs, when you light them, the generator from the power station, the frequency, if it's 50 hertz, it means that what something is changing 50 times per watt per second, because it keeps on changing. So then you can have different values of current at various points. But for the sake of calculating, you should be able to know exactly what will be the average of those. So that's when they come up with what we call the root mean square. So the root mean square current is alternating current that dissipates the same amount of energy as equivalent what? DC current. That is the alternating current that dissipates the same amount of energy. You take note, in alternating current, it will keep on what? Fluctuating up and down, up and down. So you have to take the average. That is equivalent what? To DC current. So that's why they introduce what we call what? Root mean square. So the last question, calculate the root mean square current delivered by the generator. So this one is just going and select what? The formula I root mean square is equal to I maximum. They are talking about the maximum current divided by the square root of what? Square root of 2. Maximum current. If you look on the diagram, what is the maximum current? You have something like what? 1,2. If the current do not exceed what? 1,2. It will fluctuate between what? 0 and 1,2. So, but if it's alternate current, it means that it will fluctuate between what? 1,2 and minus 1,2 if it's an alternate current. So that will be the maximum. So using the equation, you will say RMS. RMS is standing for root mean square, the equivalent current in alternate current that is equivalent what? To DC. I maximum from the graph, you can see that the maximum is 1,2. And hence is just direct substitution that will give you 0,85. That will give you 0,85. So for now, I think that will be all. So my colleague will be joining again. Thank you.
Thanks, Mr. Kwanda. Let's go back to the mechanics, and let's see what time is it. Okay, you can take a 3 minutes break to get your throat being quenched with some water or something. Then we'll go back to the mechanics after 3 minutes. I know.
Hi, sir.
Yes.
Sir, can you please do work, energy, and power? Or are you planning to do a momentum?
I was going to start with a projectile motion because it's also a confusing one.
Oh, okay.
We'll try to move faster to accommodate you guys. Nkwadi, don't worry.
Okay, thank you.
Cool.
Oh, you have this one. Where can I?
Yeah, there is one.
Okay.
But this one, so I'll try to do them faster.
Okay.
Because we left with almost 40 minutes. Time flies. These things, when you look at them several times, it's like you've done it already. Okay, we're left with 1 minute. Then we start. Okay, let's start. I'm going to try to move a bit faster so that we can cover, your work energy and the momentum within this 40 minutes. So you'll bear with me if I don't, spend more time in one question, but still I'll try to make sure that you get the understanding. So let's look at this one here. They say a ball is thrown vertically upward from the top of the building 2 seconds after the ball A was thrown upwards, the ball B is thrown vertically downward at 5.4 meters per second from the top of the same building. Both balls A and B strike the ground at time t second. Ignore the effects of friction, and given the position time, sketch graph for both balls are shown below. Now, you will remember that I said we must use the Cartesian plane to give us the positive and negative. So it will mean if I take upward as positive, the downward is going to be negative. But this is a position time graph. That's very important. And the question says, using the equations of motion only, now they're specific. The equations of motion only calculate the values of each of the following as shown in the graphs. In a different question, they would have said, use the projectile motion equations. But the first one, they want you to calculate the value of each of the following as shown at number 1 or 3.1.1 at t. Now there is t there, and they want us to use the equations of motion. So if you're going to use the equations of motion, option 1 is simply to take the distance or the displacement formula. Now you see they use the d delta y, and they use the delta y deliberately because they wanted to look at this as the y motion. Therefore, the delta y is given by initial velocity multiplied by the change of t plus half a delta t squared. You ask me, I'm not happy with the a, but I'll be happy with the g because I know that I'm talking about the gravity or gravitational acceleration. The a might be that this has been propelled, so it might be confusing. So I'll prefer the g than the a, but it's not changing the color of the cheese depending on the definition that is given. Now, if I use the option 1 to calculate the z, which is that, and I want to know that z on this. I went to the z, leaving the t is fine. You'll see why I went that route. Then you say, if I know what is the initial velocity of object A or ball A, which was given the initial velocity of 12, for how long, then that's the time that you want. This t is coming from somewhere. It's not just a t that is given. Then it says to me, if my calculation of the first question 3.1.1, it is correct, that 4 it's coming from that calculation. So when you substitute it here, you know that it has been calculated somewhere. Then here's the nice trick that we normally use. In certain questions, we know that we cannot use the, excuse me, we avoid to use the value that we have calculated for in case we've made an error. But there are questions like this one where you cannot. You must use that particular question. Now let's go back to what we're supposed to have done to show you why I wanted to start with that deliberately so that we can see the importance of why we calculate the z in that fashion. The first question that we are supposed to do is the 3.1.1. And you choose the same formula, the delta y equals to vi delta t plus half a t squared. And the correct substitution on this equation is going to give you the marks that you want. But unfortunately, or fortunately on this one, what we have is the delta y, which is still in the y direction, and that is our subject of the formula, so we don't have to play with the mathematics. But then look at what I've done here. I opted to go with the downward as positive, where else you can have the upward as positive from this graph. Now, in this particular question, you are given options to choose. So if you chose your downward as positive, it means your upward is going to be negative. Then you must, in your Cartesian plane that you would have drawn here, you'll have upward as negative and downward as positive, so that your initial vertical upward motion is going to be negative. Then you substitute it as negative. And for B, The downward is now positive. It means you are going to substitute your I as the 5.4 that is positive. But now look at this T. We use the X instead of the T. And the reason is to make sure that we differentiate from this and that. And that's where I've got the problem with the naming. But if we had the T here, for A, it would have been easy to differentiate. This was going to be TB, so that by the final answer that we get, we're able to say, this is the T that we're getting. I hope everyone can understand why this is the case. Now, come back here. You've got the X plus 2. You've got the X plus 2 to give you the time. Why is that given in that fashion? It's because you have this B, this A here is being thrown upward, and we're told that 2 seconds after ball A has been thrown upward, ball B then will follow. Hence, you've got the X plus the 2. I guess you can see why that is the case. Now, let's take this one here where you take the positive as upward and downward being negative. Now look at where we use now that difference between the T, the initial and the T being thrown up 2 seconds later, the B after the A. Now you've got this as the T minus 2. Now what you need to do here is to be able to tell if I'm throwing one upward and the other one follows later, why do I have to add? And if I'm looking at the one that I'm throwing down later, why do I have to subtract? It's because you want to take care of that difference of 2 seconds. So one of them can be added, the other one will be subtracted. Now, depending on the direction that you are taking, then you can be able to tell which one is going to be added and which one is going to be subtracted. But most importantly, if you are able to substitute here, like they say, correct substitution, you are going to get a T to be equals to 4 seconds. So either way, you'll still get the T equals to 4 seconds. So it shows that either downward or upward being positive or negative, you're still going to get the same answer. Then you can go to the number 2, 3.2 thereof, where we calculate now the Z. To calculate that Z, the same equation that we had earlier, delta Y equals to VI delta T plus half AT squared. You are going to now have the T that you have calculated, which is this point here. For both of them, they are going to reach this point at time T equals to 4 seconds. You substitute it here with a negative 9.8. And why negative 9.8 is because now we're taking the downward S negative. And the option 2 will then be to calculate using the B, because they reach the same point at the same time, then your Z must also be the same for both. That is your Z equals to 30.4. And what is this Z? Is from moving from this particular point. Therefore, follow the B. This is what has happened. But if you follow A, you go up. And the impression that you'll have, if you don't know your physics, you'll think that this one is taking longer. But that's not our interest. Our interest is from Z to this position, which gives us the Z. What is that displacement that we're talking about? So hence, the Z is the same as 30.4. It's not the path that they've been taken. It's actually the displacement or the change in position that you got from Z to the 0, hence the 30.4. Then there's another option, number 3. The option number 3 is very ruthless because it takes long and there's a lot of confusion that can come up with, but doesn't mean that they're wrong. You start by calculating the final velocity of ball A by using this equation here. Then you substitute to get to a negative 27.4 meters per second just before it hits the ground. That's what you're going to get. Then you go to this other equation that you know from equations of motion. You substitute here. I don't like the substitution. As we have heard, even with Mr. Kwanda, he said you must make delta Y the subject of the formula so that it's going to be easy when you substitute, but you're still going to get the same answer. The option 4, it says delta y is equals to the average velocity multiplied by delta t. The average velocity is given by Vf plus Vi divided by 2. Then you substitute that initial and the final, you divide that by 2, multiply by 4, then you get the 30. The option 5 is similar to what we used with option 3. So I'm not going to do the option 5 because they do this exactly the same thing. Now, the last question, or the y, rather the y part of it, again, to calculate that, which is 3.13, what you're going to do is you can use this simple equation and make delta y the subject of the formula. Why are you taking that? Look at where the y is. There is the y. Is for A, for ball A, because the one that it went up. So the difference with the Z, the delta Y from where it's been displayed is equals to the 7.35. That gives you where the Y is from here. Then for ball A again, using option 2, you can actually use the same equation to calculate the time taken for it to move from this point to that point. And you can use this equation again with the average velocity. And you started here at time t equals to 0, and it went at the t equals to 1.2. That's when it reached this position. Therefore, you can get the delta y to be equals to 7.35. Now, you must be clever to look at what is it that you are calculating and look at the graph that you are looking at, and you'll see that, oh, the reason that I got the z to be the same is because this one, after 1.2 seconds, this is when it reaches its maximum height. And when it comes back, when it reaches this position here, it will be exactly where the z is. So it means the height that we calculated on the z, it makes sense that we got that 30.4 or whatever it was before. But then for this one, somebody might say, I know this is going to be the 37.75 because they added that 30.0 on that to give them then the final answer for that, because you started with the 30.4, which is of the z, then you add what you've just calculated, the 7.32. Hence, they say the range will be given in this range, and you get your answer to be that. Then the other option that you can use is this one. I'm not going to use that option because we've done it before. Then I want us to answer number 3.2. It's very tricky. And as tricky as it is, we're going to try to get it right. Let's try that one. On the same set of axes, sketch the velocity time graph of ball A and ball B while they are in a free fall. Label graph A and B for ball A and ball B respectively. Clearly indicate on your graphs the initial velocity of each, the time at which ball is thrown, the time at which the ball strikes the ground. So you've got the 4 marks to collect from this. Now, look at what we had here. This object started from when it was given the velocity v equals to 12 meters per second, and it was thrown upward. When it was thrown upward at this point here, where I'm showing, that's where its velocity is equals to 0. So what happens is that as it's going upward, we've got this in physics, and when we look at equations of motion, we say if the velocity and the acceleration are in the same direction, the object will be speeding up. But if the velocity, like in this instant of this ball A, the velocity is upward, the gravitational acceleration is downward, it means the object must slow down, and we see that it slows down until it gets to the maximum being 0. Hence, when you look at our initial velocity, it was 12, then it's been reduced slowly until it's at 0. Then it makes a 10 to now go down, and as it's going down, the velocity and acceleration are in the same direction. Both of them are negative. It means then our object is going to be speeding up. Hence, you see this one going down up to 4 seconds. That is where it's going to be. And this is related to what we have calculated earlier in terms of the position, which was the first 3.3, 3.1.1. We got that to be at t equals to 4. That's where it reaches this, and it was speeding up in the negative direction. And the ball B started here, and it started at some 2 seconds later, and 2 seconds later is at the velocity negative 5.4. That's what we have calculated. Then it goes only in this one direction because it's thrown downward in that direction. And hence, your graph is going to be that one. But if you change the directions and take the upward or the downward as positive, then it means you'll start with the velocity being negative and it's going to be 0, then it goes to the positive. Similar with this one, it starts from the positive 5.4, then it goes upward. I hope this is clear and direct and can be dealt with. Then let's look at the momentum. How much time do we have? 10 minutes. Oh, yeah, let's rush on this one quickly. And 2 trolleys A and B of masses 1.5 and 2 kg respectively are held in a stationary position on a straight and horizontal frictionless track with compressed spring between them. The trolleys are released and the spring takes t seconds to return to its natural length. The spring then falls to the ground. Trolley A moves to the left and the trolley B moves to the right and then up a frictionless inclined plane rising to the maximum vertical height of 1.4 as shown in the diagram. Now, here's the spring is compressed, the two are attached, and when they've been released, we are told that the spring falls downward, but the trolley A travels to the left, the trolley B travels and it goes up. Then we are given the height being 1.3. From this, you can actually tell that there's some potential energy that you can actually come up with. As this is slowing down and until it reaches that, you would have learned this when you're doing the potential energy using the pendulum. And if I use the spring, same thing. Now, let's look at this. They say ignore the rotational effects of the wheels so that they don't have an impact. Then write down the principles of conservation of mechanical energy in weights. Again, as it was said before, if any of the underlying key words or phrases in the correct context is omitted, that's then that they're going to take a mark. Then you define the total mechanical energy or the sum of gravitational potential energy and kinetic energy in an isolated system remains constant or is conserved. Then you say, if you calculate then the speed of the trolley B at the bottom of the incline, here at the bottom of the incline, your total energy, remember you said the total mechanical energy is conserved. So that will mean E mechanical is equals to the total mechanical at the bottom, and the total mechanical energy at the bottom is the same as what you get on the other side, on the bottom and the top. So on the top is EP plus EK equals to the sum of the potential and kinetic energy at the bottom. So again, you can use either of these two or use the famous one that we all know, which is mgh plus half mv squared and equals to this at the bottom. But again, we need to label our masses. Remember what I said in the previous slides? If these masses are not, for some of us, because the mass is the same, I'm going to cancel them out. And I'm going to get the wrong answer because this is the wrong way of doing it. So rather, name them. This is the mass of this, that is the mass of that, so that by the time you come here, you substitute the masses correctly. You see, you've got the 1.5 and the 2. So you should be knowing which one is what. The A is 1.5 and the B is, it has the 2 kg. So that's what is very important. Then you substitute, you've got the zeros, you'll know why the zeros. At the bottom is here, the potential is 0. And this, before they started moving, the initial velocity there was 0, hence you have this. Then your final velocity is going to be 5.42 meters per second. The option 2, you use the non-conservative forces, and you say, then if I use that, I can have the non-conservative work, which is given by this. If that is equals to 0, then I'll substitute that by 0, then substitute everything that I know, and I still get the same answer. So what is important, again, as Mr. Kwanda said, know your definitions, use them accordingly. The next thing that I want you guys to do is to name your masses and every other thing that is given that looks alike, to differentiate them so that it's easy to work with them. The option 3 now is using the other definition of work. Work net is equals to delta EK, and the work net is that gravitational force in this instant is the gravitational force multiplied by the displacement multiplied by the cosine of theta, where the the theta is the angle between the product of the force and that of delta y. Now, looking at this from what is given, the delta y and this, they are in opposite direction. The forces are in opposite direction. The force and the displacement are in opposite direction. So you get the 180 degrees. Hence, we've got the 180 degrees, then it will give you the same answer. So like Mr. Kwanda said, you look at your strength and you use the one that is easy for you to work with. You don't have to do all of them. Use the one that you can work with. Then, let's see, it's the same answer. I don't want to go to that. I want the other one, the 4.31. For the t seconds that the spring takes to return to its natural length, calculate a change in momentum of trolley B. We know momentum is given by delta P, which is equals to mvf minus mvi, or we can use the impulse F net delta T is equals to this. And do I know what is the F net? Do I know the delta T? Do I know this? Then I play around with whatever that I know. I know the mass. I know the change in velocities. Do I have the time? I've done the time somewhere, so I can actually calculate and have this because of based on that, then I get this answer to be that, or negative depending on the direction that I've taken of whether this is downward or upward motion. That will give me those answers. Final one. Okay, before that, the 3.2. Again, the 3.2, write down the change in momentum of trolley A. Why do we have this to be 10.84 and we got the 10.84 there? We know momentum is conserved. So based on the conservation of momentum, then we're going to have this having the same value. That's the reason that they wanted you to give them that and tell them why. Then we're going to tell them it's going to be in the opposite direction because really it is in the opposite direction. Then the last one, calculate the speed of the trolley A after t seconds. We know the t seconds that we have that is given to us. Is it given anywhere else? No, it's not given, but you can calculate because we have the F net delta T equals to this. Then we can be able to play around and calculate whatever that we are needed to do. Then they say here, positive from question 4.31, then you can have the delta PA for object A or trolley A equals to MVF minus this, where is 10.1, which is that. The mass is 1.5. Like I said, label them correctly so that you can substitute them correctly. Calculate what is V, then you get your V to be equals to that. But what else do you know? You know that you can have this as momentum equals to that, which gives you the same answer. Or you can use the conservation of momentum. The momentum before is equals to momentum after, and you are going to be able to get the V again to be equals to that one. Then your marks are for free. For 12 marks, you get them for free. And this is basically understanding the definition and the conservation of energy and that of momentum, they give you the answers. Now, the work energy application, got 10 minutes. I hope we're going to be able to finish this. We are given a constant force F is applied at an angle of 30 degrees. Now, this is what they're saying, 30 degrees to the horizontal on a crate of a mass of 6 kg that is initially at rest and shown in the figure. A constant frictional force of 10 Newton X on the crate as it moves from rest at point A along the horizontal surface to point B. The distance between point A and B is 1.5. The speed of the crate at point B is 2 meters per second. Now, what do I need here is to also continue to draw the diagram. So what I'm going to do, and I'm going to ask you to do this quickly, just complete this to be a right angle triangle. This, we are going to have the horizontal this way, and we're going to have the vertical that way. Then you'll be able to tell which force will make this object to move horizontally. You can get data from drawing all the forces that are acting, but remember, this is the resultant force. So you have the component, the X component and the Y component. Then again, same mode of operandi with the definitions and the usages to define the term work done by a force. The work done on an object by constant force F is given by F delta X cosine of theta, where F is the magnitude of the force, delta X the magnitude of the displacement, and theta is the angle between the force and the displacement. And you'll realize that in question 4, you had to use this definition. If you understood this definition, that question is answerable. When you come here, they ask you to define this. You say, hey, these guys, they're playing. They're giving me Mahala marks for 2. Marks Mahala for being able to define what I've already used. Then the drawing, or before that, the work done on an object is the product of the force and the displacement of an object in the direction of the displacement. That's another way of defining that. And it goes back to what I said earlier, that there's nowhere where it says you must say them word by word. It's not like that. Now, let's come back to this. I asked you to draw the free body diagram, and I said I want you guys to just continue here and give me the components of F. They say draw the labeled free body diagram showing all the forces acting on the crate. The forces that are acting here, it will be the frictional force that is opposing the motion, and the normal and the weight, and the resultant net force, which is this one. But then, this is what you can draw using this minute smaller roller ball, or the square ball there that you can also use to draw. It's either of the two, you're still going to get marks. But I will be interested to get the components. Then they say, they'll give you marks to show the weight, the frictional force, kinetic friction, the normal, and this force. And those are the ones that they're interested in to give you your full 4 marks. Then they continue to say, do not penalize for the length of arrows because this is not drawn up to scale. Any other additional forces, you are going to be given this. If everything is correct but no arrows, this. If forces do not make contact with the dot, same thing that we were told earlier on. If components drawn for F, then you're going to get this. So you see that drawing those components there is still giving you marks. If anything else is not going to give you what they wanted, but you still have that. And where is that going to help you? It helps you when you do the calculation. Using the energy principle only. Now, again, what I like is that they tell you what is it that they want. They don't give you options of using any other thing. They don't give you option of using equations of motion. They want you to use the energy principles only to calculate the magnitude of the force. Now, what you're going to do, if I use this work net or non-conservative forces to calculate the work, they're going to give me a mark for that. And any other thing that I'm going to do, they're going to try to give me marks. Now, if you take this one, we know this from definition, this is the case. But because there are external forces that are acting, which is this and that, the work done by this force and the work done by the frictional force are added together equals to this. The height is very important. And here, the problem here is when we look at this with what we have on that, this has been pulled in that direction. And the substitution says this one, we're going to have F delta X cos of theta. I remember this from the definition, but where do I get it here from the diagram? I'll only get it from the diagram if I've got the right angle triangle. Then I'll see that this is the component force that they're talking about. And this will be the force that is exerted by this kinetic friction, plus half mv squared minus I squared. And the mass that is given, which is K for that crate, is 6, and 2 and 0. Very interesting. We must know which one is 2, which one is 0. Then in terms of the potential, the HF and HI, those are equals to 0. Then this is going to be 0. And we've got the initial velocity. That's when you go back to this. Constant moves as it moves from rest. That's the initial. That's where you get it from rest. At point A along the horizontal surface, the distance between A and B is given by the speed is that. Now that distance that was given, for some, they might use it here wrongly, but not remembering that there we're talking about the potential energy. So this does not have the potential energy, but it has the kinetic energy in that direction. Then you make F the subject of the formula, you substitute everything else, you're going to get your F to be equals to the 20.78 newtons. The option 2 is only to use the work net delta K, or you have this, and you can see the most informative way is option 1, because this gives you the idea of what has happened. What happened? Why don't I have the EP? But this one is just giving you this part without that. There's nothing wrong with it. It's the same thing. The most important thing is to understand and have the idea. If I use this one, this is what I'm going to follow. If I use the F net, this is what I'm going to have. And you'll see that very important. F delta X cos theta, it comes from this diagram here that I said you must draw. Then the option 3, same thing, but then here you have the directions have been changed, and now you've got what you are going to do here is to say, in this instant, because I'm looking at this traveling in that direction and the theta and the force are in the same direction, the angle is going to be equals to 0. Then you substitute again. And option 4, same thing. Using the different one, you get the same answer. So you'll see with the options, it's more of giving you the option to use the one that you are happy with. Then the final one says, a 2 kg object is placed in the crate. What effect will this have on the work done by the same force F when the crate is again moved from point A to B? Right, increase, decrease, or remains the same? You can tell. You have seen this question before. They are playing mind games with you. You managed to answer this question before, but when you answered this question earlier on, you had to talk about the increment at that point. Now here they want to see if you are one of those that are memorizing or the person that has an understanding. And if you've got an understanding, you go back to the question. A 2 kg object is placed in the crate. What effect will this have on the work done by the same force when the crate is again moved from point A to B? Because it's the same force that you are getting there, then it means it must remain the same, because the only thing that has been changed is that weight on it, but that does not change the color of a cheese because you still have the same force that is exerted. And this leads you to that, again, you must draw or go back to that right angle triangle that you have drawn to be able to get your force that makes this object to be moving in that direction. Tsiki, in high school, you can do that. In this platform, you don't do that. It's misbehaving. Please don't misbehave. So this is the same thing that you have done. So I'm not going to repeat this. And what was the last thing that you intended to do was to then do the Doppler effect. But I'll just state what is needed for you so that we can end at exactly 1 o'clock. This is what learners should master. Be able to state the Doppler effect for sound and give everyday examples. Explain using the appropriate illustrations why sound increases in the pitch when the source of sound travels towards the listener and decreases in pitch when it travels away. And be able to use the equation and be able to know when are you going to have the plus or the minus to calculate the frequency of the sound detected by the listener when either the source or the listener is moving away. And this equation is important if you know how to use those. Describe applications of the Doppler effect with ultrasound waves in medicine and measure the rate of blood flow and the heartbeat of the fetus in the womb. These are more of the practicals that you can do. Finally, that's one way that you can actually look at what we started with when we said we can do all this and look at the waves. The Doppler effect, sound, infrasound, audible, and ultrasound. And we've got examples of the electromagnetic waves being the radio waves, microwaves, infrared, visible, and this is related to the photoelectric effect. Then you can tell in everything that we have done, what you couldn't do is the Doppler effect and the photoelectric effect. Those are the two that we couldn't do with you, but we hope with the skills that we have given you, you should be able to answer those questions. I thank you. And Bukosi, are you here?
Yes, I'm here, Dr. Molefe.
Yes, yes.
Yes.
The platform is yours.
Thank you so much. Thank you so much for such a wonderful session. It has been really informative. Learners, thank you so much for joining us. We really appreciate your participation. Please note that this is not the end. Next week, Saturday, the 30th of August, 2025, from 9:30 up until 1 o'clock, we will be having our chemistry workshop. So today, we just solely focused on physics, paper 1. Next week, we're going to be focusing on chemistry, paper 2. And we have fantastic facilitators. Dr. Suela is going to be there. So please make sure that you use the same link to tune in next week, either on YouTube or on Zoom. All the best for your session. All the best for your paper. I know that you guys are going to do well. We shall see you next week, Saturday. The video of this recording will be available on YouTube. So if you want to revisit the concepts and relearn everything that was taught today, you're more than welcome to go to YouTube. Our YouTube channel is South African Institute of Physics. I'm going to repeat it, South African Institute of Physics. You can go there and you will catch up with this session and the previous sessions that we hosted from last year, even all the way to our June virtual session. All the best for your papers, and I will see you next week. Bye-bye.
Bye.
Cheers, guys.